Welcome, everyone. I'm Mellis Cody.
Hey, everybody, this is Wendy Wagner.
We'll be hosting the 9th annual South Central Alaska Avalanche Workshop from our headquarters here in Midtown Anchorage. We look forward to a robust roster of speakers this afternoon. We appreciate you all joining us on your lunch break. And I thought that we'd just dive in.
Let's dive in. Do you want to chat about how folks write if they have questions and how we're going to sort of go through the flow of that with each speaker? And there's 2 sessions today you probably saw on the schedule page, but the first session are guest speakers. And the second session is going to be local speakers. And so we're going to have all kinds of opportunities for learning this afternoon, and we'll be all finished up right around 4:15. Mellis is going to take the first half. I'm going to take the second half, and give them an idea about
in terms of Zoom etiquette, if you see a slide you really like, go ahead and do a screenshot. That's a good way to capture that information. We'll be sharing a recording of this event later. Everything gets recorded, included things that happen in the chat. We want to encourage you all to use the chat as much as possible. You can message individual panelists. You can write a question to everybody. We find a lot of times just as much learning happens in the chat as it does live on your screen. So use that as a tool throughout this workshop.
Great. And if folks have questions for presenters, there'll be about a 5-minute section for questions after each presentation. And the best way for them to ask questions is
just type them
just in the chat box, or in the Q&A box.
Chat
box.
If we're feeling more confident, we might unmute somebody, but I think for now that's going to be the best way for us to handle questions.
Awesome.
Yes, so activate your chat, get it going. We've asked panelists to monitor that, to reply directly in the chat as well. They might also drop links and other things for you to open to look at during the workshop.
Sounds super.
All right, well, thank you so much. Wendy's going to tuck into her separate room, and I'm going to introduce our first speaker. Coming to us is the director of the American Avalanche Association, Janie Thompson Nolan, is going to talk a bit about A3, where it's at. We want to start by thanking the American Avalanche Association because these regional avalanche workshops would not be possible without their support every year. So Jane, I see your screen's up. I will duck out of the way.
Awesome. Thank you, Mellis, and thank you, Wendy. I'm going to go ahead and share my screen here at the start. Perfect. Looks good. Okay. As Mellis said, my name is Janie Nolan, and I am the proud executive director of the American Avalanche Association. And we are really excited to support this Snow and Avalanche Workshop and the Chugach National Forest Avalanche Center. And it's really exciting to be kind of the kickoff. So I hope you have a great session ahead of you, and everyone has a lot to walk away with today after the workshop. For those of you that aren't familiar with A3, I wanted to take a minute before we started the workshop to really give you some background. The American Avalanche Association was founded in the late 1980s, and over the last 40 or so years, we have really been focused on membership and providing a place where people who are working in this unique profession could find community and support and growth and network. And in addition to that, we also really wanted to foster common ground within the avalanche industry. So our members are forecasters, researchers, patrollers, you name it, search and rescue, guides. They really kind of cover the gamut of avalanche industry workers. So A3 was always a place where people could kind of connect and come together. And in the last 5 years, we've expanded a little bit. So in addition to that community and that network, we also now have an education component. So we oversee avalanche education standards in the US. We also have a robust research grant program for members to apply for funding for research projects. We also offer scholarships, and there are actually two local Avalanche or Alaska folks who work at the Avalanche School who just received scholarships from A3 and VSIN. So congratulations to those folks. And we also have scholarships to attend ISSWs and conferences. So in addition to education scholarships, you can use those for professional development. And then we also have a publications branch. So A3 produces the Avalanche Review, which I'm sure many of you are familiar with. It's kind of the place for news, discussion, information around our industry. Membership comes with a subscription, and there are 4 issues every season. And truly, there is no other publication like it, so I can't recommend it enough. A3 also produces snow, weather, and avalanche guidelines, which I'm sure many of you use, and then the Snowy Torrents. The third kind of component of our work in the last 5 years has been outreach. And our biggest piece here is avalanche.org. And this is a project that we partner with the National Avalanche Center on. And it really is a place where the general public can come to find information on avalanches and forecast information. So hundreds of thousands of people are actually using avalanche.org every year, which is really great. And it's an awesome resource. And then in addition to that, we also produce a pro-employment list. So if you are interested in changing jobs or looking for jobs within the industry, A3 membership comes with a weekly email that has new job postings for Avalanche professionals. So those are that's a little bit of background of what A3 does. If you are interested in membership, if you aren't already an A3 member, we have 3 tiers of membership. The first is for professional members, and this is for folks who have at least 4 full seasons of work in the avalanche industry. And then our second tier of membership is for affiliate members. And this is for folks who may or may not be current avalanche workers, but do have at least 2 years of experience in the avalanche industry and associated education. And then our final membership level is for general members. And this has no prerequisites, so you don't have to be an avalanche professional, but you do have to be passionate about snow, avalanches, snow science, and backcountry recreation. So we kind of have made a one size, you can find your size. We have a spot for everybody at A3. And if you aren't a member, I would love you to consider joining. You can join at americanavalancheassociation.org. And I will also post my email in the chat. So if you have any questions about membership after this, you can please reach out. I'm happy to go through those. One last piece before I turn it back over to Melis is I want to provide those of you who are current A3 members with an update on 2 projects that we're working on. The first is our strategic plan. So this is something that we've been working on for the last couple of months, and many of you provided information during our research gathering phase, and I want to thank you for that. Your feedback has been hugely helpful, and it has helped us to create a plan that will really drive A3's work in the next 3 to 5 years, and a plan that has kind of input from every membership level and every facet of the avalanche community. So thank you for that. That plan will be announced in January 2022. So please keep your eyes and ears peeled. And then the other update for current members is that our annual member meeting will be on December 7th in the evening. It will be 6:30 p.m. Mountain Time. So hopefully those of you in Alaska can jump off work really quick and hop on. And so stay tuned for your email. We will be sending out a Zoom link that will be a virtual meeting, and it will include a celebration of the Avalanche Review turning 40. So stay tuned for both of those if you are a member. And then finally, I just want to thank the sponsors and supporters who make A3's work possible and make our support of this workshop possible. In particular, CIL, Explosives, Onyx Backcountry, Gaia GPS, BCA, MND Safety, and VSIN are some of our major partners, and we really couldn't do this work without them. So thank you to those folks. I will keep my eyes on the chat for questions, and I'm going to turn it back over to Melis to share an A3 video. Melis, are you there? Oh. Melis, it looked like our sound was a little off, so I'm going to share a link in the chat to that video on YouTube. So for those of you who are extra eager, you can watch it there, get the full effect.
Thank you so much, Janie. I'll see why I didn't share the audio. It was just instrumental music. And so if you had any beatbox going, you were doing fine and you caught everything that was happening in the video. But I'll make sure I have that figured out before the next share. Thank you so much, Jane. Feel free to write her any questions that you have in the chat and she'll dive in and answer them. So next up, we have our guest from furthest afield. Andrea Manberg is joining us from Finland. She's originally from northern Sweden. She's a research scientist and a professor in economics at the School of Business and Economics at UIT, the Arctic University in Tromsø. And she also works for the Center for Avalanche Research and Education. Andrea has a little bit of personal experience with avalanches. She was triggered and caught in 2014 and sustained numerous injuries. She uses that personal experience to drive her research, often in human decision-making in avalanche terrain. So thank you so much. I know it's evening there for you, Andrea, but I'll let you take it away.
Thank you. So I'm super happy to be invited. Thank you so much. I wish I could be there in person because you seem to have a much better early season than we have from the pictures that I've seen. We just have rain and the Arctic night has started to set here. So even though it's after 10 p.m. here right now, it was actually dark at 2. So I hope I get the chance to come and visit you sometime. Anyway, so can you see my screen? Is everything showing okay? I hope it is. And give a shout out if not. So the studies that I'm going to present today is a collaboration together with 2 colleagues at CARE and UIT. And I thought that I would start by, let me just put on the chat so I actually see if someone writes something. Okay, cool. Let me start by giving you some background. If this works, yes. So previous research shows that we humans, we are really suckers for relativity. Our perception of situations and things that we experience today are to a large extent affected by our past experiences. So just to give you an example, if I was there with you today and I put a 5 kilo weight in front of you, and I asked you, I didn't tell you how much it weighed, but I asked you to guess how much it weighed. But then I asked half of you to first hold on to a 1 kilo weight and the second half to hold on to a 10 kilo weight for 5 minutes. And then to pick up this 5 kilo and guess. Then if you're like most people, those of you who first held on to this light weight would think that this 5 kilo weight was relatively heavy, while the rest of you would think that it was relatively light. We also know that when we try to predict the future, which is uncertain, even though the future is always uncertain, even if we don't have any information about that future, I mean, if we were rational, we should consider the full outcome set of that uncertain variable. So this variable could be a stock, or it could be weather, or anything like that. But what we tend to see is that instead of guessing that it would be, the best guess would actually be that it would be the same as today. But most people tend to predict that it will follow the trend that we observed the day before. So in these studies, we wanted to find out if our perception of both current and future avalanche hazard is affected by what we experienced yesterday or before that. Now, this is especially relevant for Norway, because in Norway, the avalanche bulletin actually presents past avalanche danger. It is less relevant for Alaska or North America, where you don't present this. But even so, I hope that you will still find our research a bit relevant, because we might still be affected by our experiences of that avalanche danger yesterday. So the easiest way to test if we are affected by our past experiences is to present everyone with the same avalanche danger today, and then randomize what the avalanche danger was yesterday. But as we, of course, all know, an avalanche danger 3 is not always the same. We have many different varieties of it. It can be a high or a low, it can be a wind slab or a persistence slab. So in addition to varying past avalanche danger and just presenting the avalanche danger, we also presented some of our participants with information about the avalanche problem, and we used a wind slab. And this information included both a text that described the avalanche problem and information about the expected avalanche size, the likelihood of triggering, and where you could find it. So in this case, it was on the eastern side of the mountain. But then we thought that, why don't we help our participants a little bit more? So what happens if we also present a scale where we really point out which kind of level 3 this is, with a line and a point, an arrow pointing towards that line. So we added that both to the experimental condition where we only presented the avalanche danger, and the one where we presented information in addition. So we've conducted 3 studies, and I'm going to collapse the results from all these studies because the results are very, very similar, very robust. So the first study, we targeted people who work in avalanche terrain. This was road workers who work on roads that are exposed to avalanches. And this was a small sample. Secondly, we targeted students at UIT. And this was about 140 students. These were less experienced, both in terms of avalanche training and experience of backcountry touring. And then finally, we went out on social media and recruited people who tour in avalanche terrain. So this was, if we think about study 1, they had some training, but were not avalanche experts. And the last one was mostly recreational users and had quite a lot of experience. So in all of these studies, we asked our participants to imagine the following situation. So imagine that you're driving your car through mountainous terrain in March. And on the side of the road, you can see that cars are parked on the trailhead, and you can see skin tracks on the mountainside above. And the tracks are on the eastern side, and you know that this mountain has avalanche terrain. And then based on the number of cars in the skin tracks, you can presume that there is at least one group on the mountain, but you know nothing about their skill level. So you don't know if they're experienced or if they can ski or anything like that. And then finally, you can see that there's some snowdrift from the west, and you have access to this avalanche forecast on your cell phone. So people either saw that yesterday the avalanche danger was 2 and today is 3, or 4 and today is 3. And then of course we had the additional information. Okay, so after they read this scenario, we asked them 4 questions. And the first question, we asked them to think about the danger that this group of skiers was exposing themselves to. And we asked them to answer on a scale from 1, not dangerous at all, to 7, very dangerous. And then we asked them to put themselves on the mountain and try to guess how dangerous they would perceive it to be for themselves on the same scale. As a third question, we asked them how surprised they would feel if they later heard that there was an avalanche in the area. And we measured this from not surprised at all to 7, very surprised. And I should say that when I present the results, I'm going to reverse this scale so that a high number represents a higher danger. And then finally, we asked them try to predict the danger tomorrow. And we measured that from 1, much safer, via 4, about the same, to 7, much more dangerous. Okay, so let's take a look at the results. So I want to start with the condition where we just showed the avalanche danger, so no additional information. And so if I zoom in on this, the orange bars represent the average response for people who saw an upward trend, while the blue bars represent people who saw a downward trend, so from 4 to 3. And if we start to look at current avalanche danger, so perceived current risk, we see that the orange bars are much lower, or at least they're lower, and they're significantly lower than the blue bars. So what this means is that people who saw an upward trend from 2 to 3 perceive the danger to be significantly lower than people who saw a downward trend. But if we look at future avalanche danger, so the prediction, we see that people who saw an downward trend thought that conditions would be about the same tomorrow, while people who saw an upward trend thought that it would become more dangerous. Okay, so that was just presenting them with the avalanche danger. Let's see what happens when we present information. And here I've collapsed, so I'm presenting for all our questions on current avalanche danger. So this is the average. And so I need to explain this graph a bit. So if you remember from the past slide, we saw that people who saw an upward trend perceived the danger to be lower. So this graph shows the effect of seeing an upward trend. So the blue line here shows no effect if the trend did not have any effect at all. And the further down we go, the bigger is the effect, the more negative is the lower perceived danger they perceived it to be. And then on the horizontal axis, I have first people who only saw the avalanche danger, then people who saw the avalanche danger and information, people who saw the avalanche danger and a scale, and then both a scale and information. And so what we see here, we see the effects. And what we can see is that all effects are below the blue line. And the vertical bars shows the 95% confidence interval. And since they're all below the blue line, this means that the effect is significant. So basically what we find is that regardless if we add information, we still find this effect of seeing an upward trend. If we look at future avalanche danger, now if you remember, in this case, people who saw an upward trend perceived it to be more dangerous tomorrow. So if we see no effect, we would see things lying around this blue line. And the higher up we see it, the larger is the effect. And so here we see the dots are still above the blue line, but when we add a scale, it nearly crosses the blue line. So that means that when we add the scale, the effect nearly becomes insignificant. But for all the others, we see an effect. All right, so for those two, I didn't sort of control for any experience or avalanche training or anything like that. So we went ahead and checked for that, and I controlled both for avalanche training, but also other types of experience. But I'm displaying the results where I separated between people who had at least one recreational course, like a 2 or 3 level course, and people who had no formal training. So the blue line still represents no effect, while the dark lines, the maroon lines, they represent people who have avalanche danger. And the orange line represent people who have no avalanche training. Sorry, not avalanche danger, avalanche training. And what we can see here is that the dark line actually lies further down. So what this means is that the effect was actually greater, if anything, for people with avalanche training. And actually, if we look at for future avalanche danger, which is to the right here, the effect is actually non-significant for people without avalanche training. So this was a bit surprising for us. And so the question is, of course, what kind of conclusions we can draw from these studies. And it seems at least that perhaps past node stability matters, but definitely from our studies, I would draw the conclusion that past avalanche danger seems to matter for perceived risk at least. Yes, and if I would try to interpret this, I would say that Our participants seem to have thought that if it was stable yesterday, probably is today. It might get worse or worse tomorrow. If it was dangerous yesterday, probably is today, but it might stabilize or at least be the same tomorrow. We did not see any effect of information, but it seemed to have changed or reduced the effect when we added the scale. And we did not see that avalanche training reduced the effect. If anything, it increased it. Of course, when we do research, we're always constrained and usually adds more questions than answers. Two things that I would like to raise is that we used a wind slab in our scenarios, and we might have seen other effects if we have used, for example, a persistent slab. We also used level 3. And that means that the past, like the danger yesterday was level 4, which is, it's not extreme literally, but it's kind of a very serious situation and might have been different if we instead had evaluated the level 2. Then I have to ask myself if the trend effect is really irrational, because usually, I mean, past snow stability does matter. But in any case, our participants read more into the scenarios than we gave them. So if avalanche forecasters don't want people to read more into it than they present, then this might be important. And then finally, we only evaluated like perceived risk in a hypothetical scenario, and we did not evaluate decisions. It's always scary to make say something about implications from one study. We need to replicate this and do more research. If I would dare to say one thing for Norway, would certainly be to think about not presenting the past avalanche danger. For North America, where you don't have past avalanche danger, you don't need to consider this, but I'm going to dare to make one speculation. So I took a look at your, this is from Chuga Avalanche Forecast. And it's a really nice web page. And so I'm very daring now. I'm usually not this courageous. But we know that it's a lot easier to remember colors or like simple terms. And so a speculation would be that we might also anchor more if we see numbers. And so I'm just thinking, like, what if we would, instead of saying that it's considerable and showing a level 3, would present information about in words, what does a level 3 mean? What kind of avalanches can we expect? What kind of avalanche problem do we have, and how likely is it to trigger them? Or if we want to make things simple, just add the scale. All right, with that, oh yeah, right, sorry, I wanted to say that too. So one of the most important things that I think we need to do now is to study what people actually try to do. So in Tromsø, we have started a participants panel where we recruit people from Norway and Sweden and actually all over the world, where we're going to ask people to track their tours with GPS, and that way we're hoping to be able to actually measure what people do under various avalanche hazards and past avalanche hazards. And by that, I just want to show you what it can look like in Tromsø this time of the year. Right now it doesn't, it's just raining, but this is 2 years back, and I hope to meet you here in 2024 when we're hosting ISSW. Thank you.
Thank you so much, Andrea. We really enjoy your presentation and staying up a little extra late to help us. Perhaps you know this, but last year was a very tragic year in terms of avalanche fatalities in the US, and some of those things that were kind of surprising conclusions from your research, like we were feeling when we were seeing the average age of these avalanche victims kind of higher than we expected. And people that had quite a bit of avalanche training and knowledge still going out when there was considerable hazard and signs of recent avalanche activity, which, with such a surge, especially with so many people staying at home and buying new backcountry equipment, that kind of caught us by surprise too. We thought that there would be so many novices. And where do you think this practical world and research world can collide? Like, what can we do this winter to target that audience?
Oh, wow. That's like the $1 million question. No, I mean, if I had the answer to that, I would be a very happy person. I mean, I've seen that quite a lot here too, and something that I really want to study with the CARE panel is what happens when we experience prolonged periods of heightened avalanche dangers. Here we have a lot of persistent weak layers. And what we see is that at the start, people are very cautious. And then in the end, it seems like people are just fed up, and they see that someone is going out, and I just start getting nervous until you see that big slide coming. And we see the same with prolonged periods of level 3 too. And I wish I had an answer, like how can we really, I mean, that's really like, how do we then communicate the risk and keep people because that is, I mean, we are really in tune to changes. Humans are, I mean, we react to changes. We hear the same sound for a very long time. We don't hear it anymore. If we feel the same sort of pressure, we don't feel it anymore, but we experience changes. So I keep keeping that attention by changing things. And one of the things that I think that the US is really good at is providing like a personal message of the avalanche forecast, so that it's not like just the same thing over and over again, but that it actually changes, so that you sort of keep noticing like the changes, and maybe keep your attention. Mm-hmm. I'm sorry not to have a better.
Well, no, that's really good. And, as all these things come to a head, our trade publication, the Avalanche Review, the cover title was Confluences, and it's like a confluence of all these factors. And another one is just these huge changes in our jet stream and how we're seeing a change in climate. So I suspect maybe you're seeing things like that in Norway as well, where people have this go-to terrain and they have never seen an avalanche, but then it's setting up in a way that they wouldn't have seen in a 20, 30-year ski career, sledding career set up that way. Are you collecting that kind of data and seeing that where you are?
I mean, yes. I mean, it's been a longer period here, I think, where we are very much affected by climate change. I've heard, I mean, I've only lived in Tromsø for 7 years, but I know that we've had a lot more persistent weak layers during this time. And we certainly have, I mean, Troms, where I'm living, is overrepresented in fatalities in avalanches in Norway, and both among tourists, but also local people. And we had a lot of tragic accidents with really experienced and well-known people here who died last year and the year before that. And I'm not sure if it is due to climate change or just also the extreme increase in people who are out there. I mean, there are more people exposed, so we should also expect more accidents, of course, just based on people exposed to the danger.
Okay, I'm looking for any questions.
Melissa, I have a question.
Go ahead.
I'm going to jump in, if that's all right. Andrea, this is really interesting to hear an actual quantitative statistical study, because being a backcountry forecaster myself, anecdotally, we've seen this. We have a certain type of avalanche problem, or we're in a certain regime, and then things change, and it seems like people kind of have a hard time making that shift. even from when we have a lot of changing weather to more stable weather. So I feel like I've kind of seen that flip-flopped. Of course, that's anecdotal. So it's super interesting from what I do to see what you've come up with. And I have to say, I was surprised that people that have more education are more influenced by what has happened in the past. I didn't expect that. My one question for you is the moderate, if you would think you would have seen any different results if you would have had a persistent weak layer and in a moderate scenario.
Yeah, that's what I'm thinking, that because the thing is that I didn't mention in my talk is that our findings for avalanche danger is actually the opposite from what other researchers for other kind of danger, like for floodings or so on, has found. So the expectation is that you find that people will sort of think that if it was level low yesterday and it's 2 today, then the 2 will be perceived as more dangerous than if it was 3 yesterday and 2 today. So we were really surprised to see the opposite. And so that makes me think that if we would have evaluated a different scenario, the effect might actually be different. And I mean, with the if we think about a wind slab, I mean, we sort of expect it to stabilize a bit over time, but with the persistent weak layer, I wonder if they would have just sort of thought that it would be the same more or less, because it's much slower. And then someone asked me, I presented this a week ago, and someone asked me, what if you would have just presented the avalanche problem and not revealed the level? And I think it would be really interesting to do that. I don't think that we would have seen any effect whatsoever, because I don't think that people just see, oh, it's a wind slab. They don't really pay attention to, especially here, because we just presented like medium, large, likely, unlikely, and in very small text, and it doesn't mean anything. And so I talked to Scott Savage at Sawtooth Avalanche Center, and we talked about, so he was like, I want people to say, like, instead of say medium like we say here, it's actually, I think it's large where you are, say can bury and injure or kill a person. That is what medium doesn't mean anything. And I must say that I totally agree with him.
Yeah, I agree with that too. It looks like we're just hit our time mark. Is that right, Melis? I see a couple. I hope hopefully you can see those too. There's a couple more questions in the chat that you may be able to respond to.
I will respond to them before I turn off. Thank you so much for having me.
Thank you.
Thank you so much. Have a good night.
You too.
Well, that was fascinating. Get your brains ready. I'm going to invite our next speaker up to bat, Eric Peich. He's a physical scientist at the U.S. Geological Survey Northern Rocky Mountain Science Center. He's worked for the USGS since 2007, studying avalanches, snow, glaciers, and as director of the Flathead Avalanche Center in Northwest Montana. He earned his MS, Masters of Science in Earth Sciences from Montana State University in 2009. He's currently also working on his PhD at MSU. His current research focuses on avalanche frequency and magnitude and how they relate to various weather and climate processes. So today, Eric's going to be talking about unraveling avalanche frequency and climate in Montana using tree rings.
All right, thanks, Melis. And hopefully you can see the screen there. Sorry, I'm just moving a few things
Looks
around.
great.
All right, awesome. Well, thanks for having me, and thanks to all the attendees for joining us today. Really appreciate it. And so today I'm going to present work using tree rings to examine our associations between regional large magnitude avalanche activity and climate and atmospheric patterns in the Northern Rocky Mountains. But I will also be presenting a little bit and a few of our results from Southeast Alaska as well. First, I want to acknowledge my research team at NOROC, the Northern Rocky Mountain Science Center. And I have a great team. Without these folks, none of this work would have happened. And then the work that I'm specifically going to present today in the Northern Rockies, I want to acknowledge my co-authors on that project, as well as the USGS Ecosystems Land Change Science Program for funding support. So I want to start off quickly by pointing out that we all know that weather is a primary driver of avalanches when we're talking about weather and climate. However, climate drives weather, and in the context of a current and future changing climate, we need to understand, excuse me, we need to understand the avalanche frequency and climate patterns in the past. And the implications of a changing climate on avalanches can be different for different snow climates. So for example, what happens in Alaska may or may not happen in Colorado due to those regional differences. So keep that in mind as we kind of progress through this presentation. So there's been recent considerable media attention about climate change impact on everything really, but particularly or even avalanche frequency. And it's often difficult to disentangle this signal because avalanches, as I mentioned, depend primarily on weather and snowpack structure. So while climate acts as a second order driver. For example, one study found an increase in avalanches, specifically wet snow avalanches, due to warming in a portion of the Western Himalayas from the early 1900s to the early 2000s. While in the French Alps, different authors found a decrease in the proportion of powder snow avalanches. So we could probably read that as dry snow avalanches from the mid 1970s to the early 2000s. And an increase in avalanche runout altitude. And there was actually recent work that was just published that shows an increase or a migration upward in elevation of avalanche runout. So that's a pretty new paper as well. So as you can see, there can be considerable differences in how avalanches affect different regions and even at different elevations, which is why it's important for us to understand avalanche climate relationships, both as avalanche professionals and recreationists. So in this study, we wanted to answer two major questions. First, are there specific climate or atmospheric variables that contribute to years with large magnitude avalanche activity across an entire region? In this case, the region being the Northern Rocky Mountains in Montana, northern Montana. And then second, can we use the relationships that we identified between climate and avalanches to detect any trends in avalanche probability through time? So to do this, we used dendrochronology, which is the study of tree rings. And we used tree rings to reconstruct a long-term magnitude avalanche chronology. And for the Northern Rockies, we were able to do this from 1867 to 2017. And I want to stress that in this study, we define large magnitude of size D3 or larger, and most folks listening in and watching are pretty familiar with the destructive classification scale. So here's a video of what we do in the field to collect these samples. So hopefully there was sound associated with that. Otherwise, it was a super long and awkward pause of watching a video with no sound. But even if you just watched it without sound, you can kind of get the gist. We basically went out into the field. We used chainsaws, which is always fun, to cut out cross sections from dead and down trees. And we then sent those to the lab and did our analysis there. So using tree rings and dendrochronology allowed for a robust assessment of avalanche frequency across a large spatial extent. And this frequency differs across multiple avalanche climates, for example, continental, intermountain, and maritime. And our spatially extensive sampling plan here in the Northern Rockies and in the other areas that we conducted this work allowed us to be the first to examine this avalanche frequency across these multiple climates within a smaller region. And then, of course, as we finish up the other work in Colorado and Alaska across major avalanche climate types. So we did this by again, taking those cross sections, and we preferred cross sections because you can see in the lower right image here, these black lines will represent an increment borer. So maybe some folks are familiar with tree coring, and in the lower left image, you can see an example of a boring tool and the tree ring core that comes out of it. And so it's pretty small. It works, but when we take the whole cross section, we get the whole story. And so we use this as an example. So in our analysis, we actually did a little analysis of looking at if we had only used cores instead of cross sections, and we took a random sort of subset of samples of our tree rings, we found that we might have missed up to about 30% of the signals in our tree ring samples, avalanche signals. What do those samples look like? You can see in the upper left that we have from 1972 an impact scar. And then in 1950, we have a scar and reaction wood. So what is a scar? So imagine your tree in your avalanche path, and an avalanche comes down. One outcome, of course, is the avalanche comes down, rips the tree out, and takes it down slope. Another outcome is that the avalanche comes down, hits the tree, and causes damage to the outer part of the tree, or the cambium right on the outside. And what the tree is going to do then is grow around that damage, that disturbed area. And that creates a scar in the tree ring, and that black line that you can see in the upper left image. Another outcome, of course, is maybe we have a scar, the avalanche hits the tree, maybe we have a scar, but maybe it tilts the tree over in the downhill direction. So trees want to stand straight up and down. They want to get as much sunlight as possible. That's their job, is to take in water and sunlight and grow. But in this case, an avalanche tilted it a little bit. And what the tree is going to do is put on reaction, what we call reaction wood, on the downhill side. And it's going to grow more on the downhill side than it does on the uphill side until that tree is standing straight up and down again. We're pretty close. So you can see in that image again, this reaction wood, you can see these rings are much thicker on the downhill side here. And if we go to the corresponding rings on the uphill side, they are much thinner. So this is our reaction wood, and this is our compression wood on the uphill side from where the avalanche hit on the tree. So these are some examples of what we're looking for when we take these samples to the lab. Now, one of the, let me go back really quick. One of the issues is that these signals aren't necessarily unique to avalanches. They can be caused by rockfall, landslides, or even a moose walking by and rubbing up against the tree. So we, of course, selected areas where we didn't have rockfall or very much rockfall, where there were no known landslides, and we can't really control the moose. So that's why we collected a lot of samples. So hopefully the moose isn't out there rubbing up against every single tree. So here's just a map showing where we sampled in the Northern Rockies. We sampled in 4 distinct mountain ranges, or what we called subregions, with similar avalanche climate type. And the sampling strategy we used is based on the concept of scale triplet, which basically defines the spacing, the extent, and the support of our sampling scheme. And incorporating this helps us understand the nature of the problem, the scale at which the measurements or samples should be made or collected, and how we can estimate the measurements across space. So the entire regional spatial extent for this study area is approximately 3,500 square kilometers, which is about the size of the advisory area for the Flathead Avalanche Center. In this study, we included both transportation corridors and popular backcountry areas in northern Montana. John S. Stevens Canyon in the southern part of Glacier Park contains US Highway 2 and the BNSF Railway. And of course, we also sampled in the central part of Glacier Park along the Going to the Sun Road. So just another quick image to kind of help look at some of these signals that we see in the tree ring. And as I mentioned, there can be numerous response types. And this shows a few examples of those prominent types of growth disturbances or signals. And we used a scale from 1, which is obvious avalanche scar. You can see there the C1, and to 5, which is a growth disturbance, but we're not really certain it was an avalanche. You know, it could have been, again, something else. And you can see the impact scar here from 1956, which was rated as a C1. And then we have other signals here where we just have reaction wood, so not associated with a scar. And we would probably give those a C2 because there are numerous years, because it takes a while for that tree to actually stand upright. There we go. All right, so how do we actually know that it's an avalanche year? So how do we distinguish between an avalanche response, the signal, from the noise? Well, first, we sampled, as I mentioned, mostly cross sections instead of just cores, and this allowed for a greater number of higher quality responses. It also allowed us to filter out responses from external factors, like I mentioned, rockfall, landslides, et cetera, because we were able to look at the whole tree. We also applied a series of filters using thresholds that were based on the sample size and the number of growth disturbances per year. And then finally, we placed more weight on higher quality responses. So those C1s that you saw in that last image, those were weighted more heavily than C2, than C3, and so on. So what did we find? We ended up with 673 samples from 647 trees. We identified over 2,000 growth disturbances, and we found that with our trees, the mean age of our trees was 73 years. We constructed an avalanche chronology from 1867 to 2017. So within that period, that we identified 30 large magnitude avalanche years across the region. So this plot shows on the top panel there, panel A, we're looking at snow water equivalent, and the green line is the mean, so the average snow water equivalent across the region. You'll notice that the timeline here is from 1950 to 2017, and we limited it to from 1950 to 17 because we were limited by the time series length of the climate data. We can see that prior to the 1990s, let me get there. There we go. So everything, roughly left of 1990, that all of the avalanche years we identified from the tree ring record were associated with above average snow water equivalent. The red box delineates that 7 of these, though, reconstructed years occurred during years with below average snow water equivalent after, right around 1990 and after. So on average, large magnitude avalanche years had a higher total seasonal SWE and snow depth anomalies that you can see in panel B in the lower left. So the blue boxes being avalanche years, the red being non-avalanche years. And similar to what Andrea was showing before, this thick black line right here is, in this case, statistically significantly different than this thick black line here. And so we have higher, in years, the avalanche years that we identified, we typically have higher snow water equivalent and snow depth, HS. And then you can look at this panel over here, and we typically had higher precipitation in January, March, and annual, which is really winter. So I am highlighting these because these are the 7 years, and keep that in mind because we're going to revisit this later and talk a little bit about those 7 years from 1990 to roughly right around now. So we used a statistical technique called principal component analysis to essentially combine similar variables into major, what we call principal components, all right, or PCs, we'll call them for short. So the largest contributors to PC1, so we took these variables and they sort of separate out into correlated or associated or similar variables. So the largest contributor to PC1 here in panel A, associated with large magnitude avalanche years, are positive anomalies, so years with positive snow depth or above average snow depth and snow water equivalent. It's also associated with negative anomalies of the Pacific Decadal Oscillation and the Pacific North American Index. So we also looked at atmospheric circulation and these teleconnections. This suggests that PC1, so principal component 1, represents increased snowfall and storminess. And this is essentially the long-term variability of our snowpack and low pressure systems. That's kind of how we can think of PC1. PC2 represents winter warming temperatures on avalanche years in our data set. And the major contributors to PC2 are warmer temperatures and positive anomalies of the Arctic Oscillation. And so the positive phase of the Arctic Oscillation, or AO, is often associated with fewer colder outbreaks in the mid-latitudes. The main avalanche years associated with principal component 2 occurred during winters with above average temperature and positive AO values. So our PC3 here represents the short-term variability of our data set, as mean winter El Nino, or ENSO, is the largest contributor. And then we also have here in panel D, PC6, and we use PC6 because it represents the precipitation, specifically the spring precipitation component. And I'll talk a little bit more about why I'm highlighting PC6 here in just a second. But basically, we used a generalized linear regression model to look at changing avalanche probabilities through time. And those results from that model suggest that PC1, 2, and 6 are actually significant predictor variables for large magnitude avalanche years. So let's take a look at what else we found. So we found a slight but significant decrease in the probability of large magnitude avalanche years from 1950 to 2017, as you can see in the upper left plot. And this roughly translates to about a 2% reduction in avalanche probability per decade. The trend of maximum snow depth decreases over time, as you can see in the lower right plot. And again, as I mentioned, this is the largest contributor to principal component 1. And accordingly, the probability of an avalanche year decreases as PC1 becomes more positive. So you can see there the arrow pointing to the right is the right side of the figure means less snow and high pressure, and you can see that the black dots basically go down, so the probability of an avalanche year becomes lower as we get less snow and higher pressure. So there's a decrease in snowpack depth over time, which was the most influential driver. However, this decrease is buffered by warming and spring precipitation increases. So a slightly higher probability with warmer temperatures and increase in spring precipitation. So going back to this plot, we wanted to see if we could sort of tease out a signal to help explain the occurrence of these large magnitude avalanches during years of below average snowpack anomalies. The small sample size kind of limited us to actually, try and determine any drivers related to that. And given the lack of snow structure data, we're sort of limited in our interpretation of whether those 7 years can be attributed to one large storm and an antecedent or existing weak snowpack during an otherwise low snow year, or whether it's a general change in avalanche character. So given that our results suggest that temperature is a significant driver of large magnitude avalanche years, as part of PC2, it is possible that large magnitude avalanche years are due to a changing avalanche character. In other words, there may be a shift from large magnitude years influenced primarily by storminess and abundant snowfall to years becoming increasingly influenced by warmer temperatures and wet snow avalanches. So not like this complete distinct shift, but an increasing influence by a changing climate. So really quickly to summarize, we found that as snowpack and low pressure persistence decreases and the probability of a year being one with large magnitude avalanche activity also decreases throughout the region. We found that the probability of large magnitude avalanche years decreased in the region from 1950 to 2017, but this is buffered by warming and increased spring precip. So what? The regional snowpack losses drive the frequency of large magnitude avalanches. Will warming play an increasingly greater role? Well, that's still remains to be figured out of how much of a role it will actually play if we can, and hopefully when we can model into the future. And then understanding climate avalanche relationships helps place in context and prepare for, these sort of large or extreme, or even as Melis mentioned before, these sort of 1 in 20, 1 in 30 years. So I think I'm running out of time a little bit, but I just wanted to touch on what we're doing. We are doing similar work in Southeast Alaska. The ultimate goal, as I mentioned earlier, is to examine avalanche climate relationships in each of these regions and then compare to sort of hemispheric wide climate drivers across different climate types. So we collected over 400 samples in Southeast Alaska across 6 avalanche paths, 2 on Douglas Island, if you're familiar with the area, 2 near Snettisham, which Port Snettisham there supplies power to Juneau and surroundings, and 2 near a mine north of Juneau. We had nearly 400 samples with almost 2,500 growth disturbances. The mean age of our trees sampled was nearly 200 years, so a lot older than in the Northern Rockies. And while we had trees dating back as far as 1396, we developed a chronology from the mid 1600s to 2019, which is still pretty cool and pretty long. And we identified 38 avalanche years across the region. You can see here another box plot from the 3 different regions and then the entire region all grouped together. And what we're looking at here is just the return intervals of large magnitude avalanche years. You can see that the 3 regions, and then including the region as well, are sort of show anywhere between, depending on the subregion, 5 and 10-year return interval for a large magnitude avalanche cycle on average. So we took a look at a few variables across the winter months, climate variables, comparing years with large magnitude events and years without. And note that precipitation and snowfall was typically greater from January through April in years with large magnitude avalanche events. So the blue line there. So we took these variables along with El Nino, La Nina, and the Pacific Decadal Oscillation indices, and we use them as inputs in a logistic regression model. We found that February and March precipitation to be significant predictors in the model. And when we look at them, just February and March precipitation in a univariate analysis, we can see that there is a statistically significant difference in February precipitation of those avalanche years, again in blue, versus those non-avalanche years in red. So we're currently wrapping up the analysis and writing the paper, so stay tuned for more on that topic. And with that, thanks again for having me, and I'll take any questions if we have time.
Eric, that was great. This is Wendy.
Hey.
It's awesome to see the southeast portion on there. I don't know if Mike James is gonna chime in here, but I think we maybe have time for one quick question. I'm gonna see if there's anything just popped up in the chat. Oh boy, I don't see anything. Trying to go through it quick. My one question is, what was the most, I guess, unique or interesting thing that came out of this? Because, climate change and having different kind of avalanche problems up here, we talk about as well, but I was curious on the most sort of something you didn't expect.
I guess, going into it, we didn't know, the hypothesis sort of was, we would see some sort of change in avalanche frequency. In the Northern Rockies, so far, this decrease in the trend, this decreasing trend of large magnitude avalanches, or the probability of it being a year with large magnitude avalanches, it wasn't necessarily surprising, and it's a slight trend, but I think it's an important one, because I think especially in maritime climates, and obviously the Northern Rockies is an intermountain climate, but I think it's important because this is the sort of, these lower elevations where we're seeing less snow, I think has a lot of implications, from infrastructure planning and highway and railway forecasting, because we might see this decrease in, from a forecasting perspective, we might see this decrease in probability year after year, but that doesn't mean we're not going to see large magnitude avalanches. So, as I mentioned in the talk, like all it takes is one really bad snowpack year and just one storm in a given year, and you can have a huge avalanche that, then reaches the road and takes out a bunch of infrastructure. And so I think that's the important thing to note, is that, we're still going to see these, but maybe this changing character. So now we might see not this like step change shift to wet snow avalanches or more of them, but an increasing influence of those types of wet snow avalanches.
Awesome. Well, thanks so much. If you don't mind looking at the chat at the end of this and seeing if anybody has any follow-up questions for you, but thanks for taking the time to speak with us up here.
Yeah, thanks.
Thank you so much, Eric. Well, I'm going to try to share a video message from one of our sponsors. Hopefully the audio will work out. I think maybe the earbuds of me and the speakers are interfering with sharing audio. So I'll give this a shot and then I'll introduce our next speaker. Thanks to Backcountry Access for supporting this event. Well, next up is Travis Feist. He's a field observer and the education coordinator at the Sierra Avalanche Center. Before he started there, which is in 2010, he worked for years as a ski patroller, a guide, and doing avalanche education, not only in North America, but also in Argentina. Travis has taught ARI courses, ARI instructor training courses, and now he focuses a lot of his education on the motorized community. He teaches Pro 1 and Pro 2 courses for motorized groups. He's not working for the Sierra Avalanche Center. He's teaches wilderness education and outdoor leadership at the Lake Tahoe Community College. When he's not on a snow machine, he'll reluctantly slow down and ski with people like me. So please welcome Travis Feist.
How's it going, everybody? I don't think my video is showing yet. There we go.
Got you now.
Okay, great. Well, thanks for having me. Let's share the screen here. I'm going to talk to everybody today about the Sierra Avalanche Center's daily flow. This is the risk management process that we developed. We teach our motorized students. And one thing that's a little bit interesting about it, it's not just the risk management process, but it's also the structure of our classes. So the concepts match the process, and I'll explain that a little bit further. This is the daily flow right here. These are actually, these images are two different stickers that we give to students so they can go right onto the snowmobile. They're front and center the whole time. We also have a book, we have some handouts, and we have a video that explains this process much more efficiently than I can. So I'll show you the video a little bit later. I want to start off by kind of explaining why we decided to break from traditional skier-based avalanche education, which tends to be more conceptual. So I'm sure everybody's familiar with the avalanche triangle, and this is what most ski-based avalanche classes are based off of. And the idea is that if you teach the concepts of weather, terrain, and snowpack, then your students can avoid being the trigger. Very often the link between the concepts and the action is a little bit tenuous, but I do think that generally works with a skier audience. If you think about the pacing of backcountry skiing, it's very slow. Your partners literally march in line behind you in the skin track. There's very few decisions being made throughout the day. Probably the most important one is at the truck when you decide what your ascent route is going to be, and then your ascent route generally determines your descent route. But on the way up, you don't really have to worry about your partners just darting off the skin track by 100 yards or more. And then on the way down, we'll make a fairly binary decision when we get to the top, like, are we actually going to do this or not? I'm not sure how many people, when faced with the image on the right here, are actually going to talk their friends out of it. And then gravity keeps your partners, again, generally in line. Like, there might be a few things to bip and bop off of along the way down, or things to avoid. But it's very linear and it's slowly paced. So I think students from traditional avalanche classes, when they graduate and then they go out with their partners afterwards, they have time to discuss those concepts with their partners and make decisions. And so I think that traditional conceptual model of avalanche education works for them. But think about what we do on snowmobiles. This is actually a very brief GPS track. This is probably about 30 minutes worth of riding. It's almost all in avalanche terrain, I think, at least in the run out of avalanche terrain the whole time. And this is just one person. So consider that you might have 4 or 5 partners with you, and they're not simply going to ride right behind you in line. They're going to be doing their own kind of parallel thing. And then multiply this by multiple drainages throughout the day. And it could look fairly chaotic. And so a lot of students, when they take the conceptual based classes, might tell their instructor, well, I get it. I get these concepts. I understand how weather influences the snowpack and causes avalanches. And I understand what the terrain influences as well, and how to avoid avalanches. But what do I actually do when I'm out in the field? Like, how does that influence my day? And so for the motorized users in particular, when things are this chaotic, we decided that we needed something a little bit different. I got really lucky several years ago. I was able to meet and ride with some of the top snowmobilers in North America. And these are all folks who took traditional conceptual avalanche classes themselves, but then they are guiding motorized clients. They're teaching skills clinics. Sarah Carter is actually in this picture. I don't know how many of you guys know her. My guess is several do. So she deserves a lot of credit for this as well. And basically what we did is we rode with them for a few days and asked them what they actually did with their clients, how they managed to avoid avalanches. And what they told us was that it wasn't the concepts that were as important as the process. So the way they structured their day was the way they avoided avalanches. And that was a pretty important takeaway. What it reminded me of, I'm guessing some people on this call are old enough to remember back in the early 90s when media kind of first started focusing on so-called extreme sports. Everybody was really shocked at how the athletes were actually surviving, considering what they were doing. And so social scientists and psychologists started studying them, and what they discovered was they were all following rituals. A lot of them didn't realize they were following rituals, and that's why it took the researchers to tease this out. But most people participating successfully in extreme sports were following rituals. And so, that kind of spawned a whole series of borderline self-help books about how to find the flow. The idea is that if you follow these rituals, then when it comes time to make decisions, you're in the zone, so to speak, and the decisions flow naturally. And so that's what inspired the daily flow. And looking at the left, I'll just take you through the first few bullet points here and explain how we teach it. Because I do have to admit, that the whole idea of having a 3-step trip plan is nothing unique, the before, during, and after trip plan. But what we do a little bit differently is we connect the concepts with the actions. So the first thing that you do is consider your partners. That's the first thing we teach. That's when we teach about the human factor and what makes a good partner, and how to factor your partners into the rest of the plan for the day. If the next thing you do is anticipate conditions, that's where we talk about weather and snowpack and avalanches and how to read the avalanche forecast. The next thing we do is create safety margins. That's when we teach our students about avalanche terrain, so on and so forth. And then the sticker on the right, the conditions and terrain alerts, that's to help maintain awareness of conditions and terrain as we ride. So it's both the process and the concepts all tied together. And again, the video is going to explain it a lot better than I can in just a few minutes. I think the video is just 5 minutes long. So Alice has that. Let me exit my screen share so that she can show that video.
We all want to live to ride again, and we owe it to our loved ones and our partners' loved ones to return safely from every ride. But just because you made it home again, how do you know if you were doing it right or just got lucky? The Sierra Avalanche Center has a risk management process to help you do it right. It has flow, like a good ride should, so following it doesn't interfere with your riding day. Who else is going is a more important question than most of us realize. Over 90% of avalanche accidents are caused by the people involved. Clearly, the people we ride with and the choices we make together are at least as important as other factors like conditions and terrain. You might try to be exclusive about who you ride with, but in reality, none of us makes the perfect riding partner. Consider the qualities that each person contributes to the team and plan the day accordingly. A great riding crew is the foundation for a successful day. The Sierra Avalanche Center publishes the avalanche forecast at 7 a.m. Teach yourself how to get the most out of it by reading it every day. If you find any unfamiliar terms, use the links to learn more. The avalanche problem starts with the avalanche type. Each type behaves differently and deserves different safety margins and group management techniques. The next component of the avalanche problem is the anticipated location. The locator rows shows the general aspects and elevations where that avalanche type will most likely exist. It's a broad generalization across the whole forecast region. The likelihood and size are specific to that avalanche problem. Anything bigger than a small avalanche is big enough to bury or kill a person. Problems with higher likelihoods and larger sizes push the danger rating higher up the scale. The weather forecast comes from the National Weather Service in Reno. It's specific to the mountains and avalanche conditions instead of the more urban-focused forecasts you'll find elsewhere. If you're planning to ride in an area without an avalanche forecast, factor a high level of uncertainty into the rest of your plans and keep your terrain choices very conservative. Mountain riding is too dynamic to make specific linear plans. Instead, before you leave, create safety margins based on your riding partners and anticipated conditions. Agreeing to these in advance leaves options open and makes decisions easier once you're out on the snow.
Morning. How's it going? Good, how are you? Good, man. Check out the forecast? Yeah.
Don't forget the details, including plans for when something goes wrong. Making assumptions about the details without actually discussing them can increase the consequences of seemingly minor mistakes.
Seeing as the day moves on, we might want to watch out for this area.
Now, remember you guys, we were looking at the forecast, moderate danger rating today. Got isolated wind slabs out there and then the potential of loose wet in the afternoon. So stop to talk several times throughout the day. Your first stop should be right at the trailhead to review your plan and check emergency gear. Manage your group for conditions and terrain by using the right spacing, spotting, and communication techniques. If you're not in avalanche terrain, the buddy system is a popular spacing and spotting technique. Make sure you keep an eye on each other and use radios and hand signals to communicate. In avalanche terrain or underneath it, use spacing and spotting techniques that only expose one person at a time. If someone gets stuck while riding in or under avalanche terrain, don't go help.
No, you guys have just made it up here. Go ahead and send the next rider.
Excellent, Duncan. I'll be heading up here. 30 seconds.
Maintain awareness of conditions by using the Conditions Alerts checklist. Do you see any current or recent avalanches? Are there other signs of instability like shooting cracks on test slopes or reactive snowpack tests? Does the advisory mention a persistent problem, or are there facets in the snowpack? Is there current or recent loading from snowfall, wind, or rain? The more conditions alerts you observe, the more terrain alerts you need to stay away from. Maintain awareness of terrain by using the Terrain Alerts checklist. Are you about to go onto slopes steeper than 30 degrees? If so, is it an obvious avalanche path? Are there trigger points or terrain traps? Does this terrain match where the forecast warned avalanches could occur? At the end of the day, have a quick debrief, not only to discuss what went well, but also to acknowledge mistakes. Submitting observations to the Avalanche Center is a valuable way to end your day. Summarizing the conditions you observed helps with lifelong learning and also contributes to the greater community. Following this daily flow is not only an effective way to manage your avalanche risk, with practice, it's also an efficient way to structure your ride that feels natural and doesn't get in the way of having fun on the snow. For more information or to support the Avalanche Center, please visit the Sierra Avalanche Center website.
So Ava asked in the chat for a link to that video, and I'll definitely look it up and post it in the chat box. Any other questions about the daily flow that we teach here?
Travis, I really enjoy that because you hear this a lot, like tokenism these days, but I feel like that happens with avalanche education, where we take all these tools that we use to create avalanche education for non-motorized groups, and then we throw in a picture of a sledder and then we call it good. And what really struck me was one of your first images just showing like how their movement through avalanche terrain is so different, especially as a group when you're saying they're not tip to tail, traveling. Are there a couple more things you could highlight that you see as like some of your biggest emphasis as you've kind of transitioned to doing mostly motorized education?
Yeah, well, so backcountry skiers, I think, paint between the lines, and snowmobilers go way outside the lines, right? And it's a lot of fun, honestly. I enjoy teaching the classes. I enjoy riding. It's challenging as an instructor to keep the reins on the group. And I think that, I often joke everything I know. I still do some ski guiding, and everything I know about ski guiding, I learned on a snowmobile. And it's really interesting for me to kind of think about what graduates of the classes are going to be able to apply with their friends, and how difficult it is to actually manage your group. Because here I am, in a formal position as an avalanche instructor. I have students who actually, they're signing up specifically for the class. It's not just a random group of friends heading out for the weekend. And and it's still difficult for me. So I'm sure it's incredibly difficult for the graduates. And that's why we need to give them simple tools that are easy to follow. That's one of the things I really like about the stickers, because students can take several of them home and then give them to their student or to their friends so that everybody kind of knows what's going on for the day.
Yeah, and the motorized crew, they're so good about communicating, and between the noise and the machine and the helmet and everything, having a link radio helps a lot, but you don't see that as much, I'd say, in non-motorized groups, even though FRS radios, they hardly cost any amount of money. Would you say that that additionally would be something that you'd recommend for people on 2 sticks?
Yeah, of course. And I think that's changing. At least around here in the Tahoe region, I do see more and more people using radios. And a close friend of mine who's a very savvy backcountry rider who, he's been teaching forever. He's an Avalanche pro. He took his wife out one day skiing in the trees and just made assumptions that she knew to stop and regroup every now and then. I'm talking about snowboarding, not snowmobiling. And she just drained it all the way to the car, right? And had they had radios, it wouldn't have been that big of a deal. And I think that that's just one of, dozens and dozens and dozens of stories that, would have been different with radios, and people are realizing that.
Yeah, well, I appreciate you sharing your stickers. We staged some of these at the Big Snow Machine shop, and one of our event sponsors, Alaska Mining and Diving. We have a stack there. We have some here at Alaska Avalanche School. So that's definitely a nice resource for you to share with us. Were there any other questions, or Wendy, did you have one?
There's actually, Travis, you have a few questions in the chat, and I think we have time. I'll just ask one. The first one that came in from Jared, he says, as snow bikes become more popular in the backcountry, has there been changes in the types of avalanches and locations? Snow bikers tend to ride in the forest more, where avalanche snags are a higher consideration during runoff assessment. Oh, maybe I'm reading that a little funny, but maybe train traps hitting trees is what he's getting at with that. And they also would like to know where he can get those decals.
Sure.
Covered that.
Well, first, as far as the stickers go, I'll put my email address into the chat box, and I'm happy to share the artwork with people. So there are a few other avalanche centers and a few snowmobile clubs that have printed their own. So you can change the coloring and the logo around if you want. I'm also happy just to throw a box in the mail for anybody who wants them. So I'll add my email address there. Back to the snow bikers, speaking anecdotally, it definitely, it's a different approach to terrain. And I find that because snow bikers are looking for strange little nooks and crannies slightly differently than snowmobilers are, their group management seems to be a little bit loosey-goosey. It's I think that they are more accepting of their partners just kind of disappearing off into the nooks and crannies. And so I do think they need tighter group management, and I think that's a cultural issue more than anything else. We have a lot of snow bikers taking our classes, and that is the most difficult group to manage, for sure.
Thanks, Travis. I think, Melis, you want to close down?
Yeah,
Travis,
thank you so much.
have a bunch of other things in there I'm just looking at too, if you don't mind taking a few minutes.
Sure, yeah.
Yeah, thank you so much for some of our out-of-state visitors. Janie with the A3, Andrea calling in from Norway, Eric, thanks for being so active on the chat here at the end with the science questions, and Travis, we really appreciate you touching on that. Here we've been really putting a lot of focus on trying to expand our outreach to motorized audiences, and the tools that you have are top notch and translate really well to our community. So thanks for explaining it and sharing it. Really appreciate it. I'm going to turn off for a little bit. We've got a short break, a little under 15 minutes. I'm going to share some slides from our sponsors and a couple of videos. Wendy's going to lead the second session, starting at 1:45 our time with Kyle. So enjoy the break. We'll see you in a few. Thank you so much to Powderhound Ski and Bike in Girdwood. They just got a remodel with 50% more floor space, which comes with a ton of new products. They love talking to their customers and sharing their gear and knowledge. Powderhound staff knows their products inside and out, located at the base of Alyeska and 20 minutes from backcountry access, make it convenient for them to answer any questions and match you up with the right gear. Powderhound is a full service ski and bike shop capable of fine tuning any issues you have with your ski and board equipment. Make sure you stop by. They're open daily from 10 to 6 and follow them on Instagram at PowderhoundAK for the latest and greatest. Ski AK is Alaska's year-round premier custom alpine ski shop for equipment and service. They have a recreational, adventure, and competition focus with expert staff providing local knowledge based on their Alaskan experience. Ski AK offers the best technical recommendations to assist with your selection of alpine skis, boots, bindings, and accessories for all mountain resort skiing, backcountry travel, heli skiing, USSA, and FIS competition. Their back shop, staffed by some of the best ski techs in the industry, provide US ski team athlete equipment and race support for the World Cup. Locally, Ski AK provides race service, base grinds, full tunes, mounts, hot boxing, and complex repairs for all alpine, telemark, Nordic combined, randonnée, skimo, splitboard, and snowboard equipment. Ski AK offers complete custom footbed fabrication and alpine hard boot fitting modification services. Located at the Metro Ball, come see these fine folks at Ski AK. Alaska Mining and Diving has been a huge supporter of snow community safety and avalanche forecasting centers. For years, they have been donating loaner sleds to Chugach National Forest Avalanche Center and Hatcher Pass Avalanche Center. This season, they're donating a loaner sled to Alaska Avalanche School to use for our courses. Tonight at AMDS at 6 p.m., they have a free avalanche awareness and transceiver practice session with Skidoo traveling instructor Mike Duffy. So show up with you and your partners and your gear tonight at 6 p.m. at AMDS in Anchorage. Welcome back, everyone. Thanks so much. We appreciate all of our sponsors and the support we've had this year to offer this virtual conference. Wendy's going to be the MC for the second half, guiding conversations with local forecasters, both from the National Weather Service, from regional avalanche centers, community snow obs. So take it away, Wendy.
I'll take it away. Thanks, Melis. So we have a pretty fun last half of the workshop with local folks. And our first title is the 2021 Easter Avalanche Cycle at Hatcher Pass and Associated Infamous Drizzle Crust. And many of you may recollect all the events that happened last spring at Hatcher Pass. The cool thing is we have 3 people presenting different aspects of this whole cycle. And it's going to be about an hour and 15 minutes for these 3 presenters to talk about this cycle. The first one I'm going to introduce, and that'll be Kyle Van Pearsum. And then when he's finished, I'll introduce Allie Barker. And then when she's finished, we'll talk with Jim Kennedy. And so I'll introduce all of those when they come up personally, and then we will do the questions for that whole Easter cycle at the end of the hour. So you can always stick them in the chat, but we will put the questions to all 3 of those folks at the end after everyone's spoken. And then we have a few presentations after that to close the workshop. But to start this exciting Easter avalanche cycle talk will be Kyle Van Pearsum. You guys may recognize his name. He's been with the National Weather Service as an operational meteorologist for several years up in Alaska. And actually, he's now moved into the coolest title, I think, ever, and it's Senior Hydrometeorologist with the Alaska Pacific River Forecast Center. So that's where Kyle is now. He also is a weather officer for several years with the Air Force as an Air Force meteorologist. Thank you, Kyle, for your service. And amongst other things that we don't have time to go into, I do want to say he is an instructor for the Alaska Avalanche School. So Kyle, you want to share your screen?
All right, I think my mic's on.
There we go. Yep, and we have your screen.
Okay, great. So thanks everyone, or thanks Wendy, and thanks for everyone for coming out. So this is going to be a pretty cool talk. I'm going to be talking about this event in terms of the foundation of the event, and that's the drizzle crust. So Allie is going to go more into the snowpack leading up to the avalanche cycle, and Jim is going to give his perspective from the DOT side of things. So in case to kind of back up, if people weren't aware of what happened during this event, back in end of February, there's this really weird thing that happened in the Talkeetna Mountains in the Hatcher Pass area. And we had freezing drizzle that fell and created a huge or really thick, widespread drizzle crust on the snowpack. And through the course of the next month led to one of the biggest avalanche cycles that Hatcher Pass has seen in quite some time. So for my take, I'm going to talk about how this drizzle crust formed. It took a lot of people by surprise, even seasoned meteorologists and forecasters. So before I start, I want to thank some of my colleagues from the Weather Service that we just kind of put our heads together and talked about this event and talked about how, if it's possible to forecast it, like what happened. So in particular, Dave Levin from the Arctic Test Bed in Alaska region, he's on. So I just want to say thank you to him for helping out with this. All right, so let's get started. So if we go back to February, let's talk about the setup with this drizzle crust here. So kind of a blurry surface chart, but this is the morning of the 27th, and this is when that drizzle crust formed. So what you want to look here, there's an area of low pressure that was sitting over the Bristol Bay area. And there's a weak front that was draped across the southern half of the state. Now, this low pressure system was only 998 millibars, not super impressive, but it was to our west, which meant that we had southwest flow, which we know, if you're familiar with the area, is really good for bringing snow into the Talkeetna Mountains and Hatcher Pass in particular. So leading up to the event the day prior, this is the AM mountain rep forecast on the 26th. So this will be Friday morning, and the event happened Saturday morning. So 24 hours out, the Weather Service had put in about an inch, was forecasting about an inch of water over the next 24 hours, with snow amounts ranging from a foot to about maybe a foot and a half in the higher elevations. With the remarks down here showing that the heaviest snow they were looking at, occurring Friday afternoon and into Saturday morning. If you look at the Hatcher Pass, the Independence Mine snow tail at Hatcher Pass, what we see is the forecast is actually pretty spot on in terms of water. We had about an inch of SWE that was recorded at the snow tail, but the snow amounts, according to the snow depth sensor, was only about half of what we were expecting, or even less than that. So something strange kind of happened here. The first part of the storm, it was tracking pretty well. We got about 6 inches, but then something happened here in the morning of the 27th, where we had an additional 3 inches of water that was picked up on the snow pillow, but the snow depth sensor stayed flat. And people were really surprised at what they found in that morning when they went up to Hatcher Pass. So here's some OBS that came in from the 27th. So we got 1/8 of an inch of rain crust all the way up to 4,000 feet, centimeter and a half rain crust overlying the new snow, thick rain crust up to 3,600 feet, 1/8 inch rain crust over 6 inches of light snow. And then this whole area covered from top to bottom, 1/4 inch of ice. And I like this. We watched a single snowboarder try to go down microdot shoulder, and it looked harsh. And I bet it was horrible with ice layer up to 3,500 feet. They were surprised to find a nice rain crust after getting out of the car. And here's an image from Hatcher Pass observations here that someone sent in of that drizzle crust. So if we go back to this chart here, the snowtail station, this period where we saw an additional 3/10 of an inch of water with no snow depth increase, this is when we saw the freezing drizzle. So unfortunately, people were expecting this, and instead they got this. They got beautiful, breakable 1/4 inch of freezing drizzle crust on top of that new snow. So it should have been a foot of snow. Instead, we got 6 inches of new snow, and with a crust on top of that, and led to some beautiful survival skiing. So besides crushing all hopes and dreams that morning of a beautiful powder day, this drizzle crust actually laid down the foundation to one of the biggest avalanche cycles in Hatcher Pass in recent memory. And so Ellie and Jim will go over more about that. But to back up a little bit, to understand what happened, we have to understand how snow forms in the atmosphere and different types of precipitation types that form. To do that, meteorologists look at upper air soundings. So if you haven't ever seen an upper air sounding, I'll kind of explain it to you. So what it is, it's a vertical profile of the temperature and dew point at a point in time at a single location. So this red line represents the temperature, and this blue line represents the dew point or the moisture. The closer these are together, the more likely you're going to have cloud cover. Now the temperature lines here, I'll overlay the 0 degree isotherm, are actually skewed. So the temperatures kind of go from the bottom left to the top right. Now they do this so we can fit the whole profile onto the same graph. So these are launched twice a day across the world. Thousands of locations do it at the same time. We have a balloon that we launched from the Anchorage Forecast Office here at Sand Lake at 12 Zulu and 0 Zulu. So that's right now it's 3 a.m. and 3 p.m. And so if you look at this profile, this example here, everything to the left of the freezing line is below freezing, and everything to the right is above freezing. So we can look at this and say, oh, the freezing level here is at about 550 millibars, or which is equivalent to about 16,000 feet. So if we were to expect precipitation to fall out of this sounding, we would expect it to be all rain. And in fact, this sounding was taken in the middle of a hurricane. Now, conversely, if the entire sounding is below freezing and it's saturated, then you'd expect snow. It's not rocket science, pretty easy to understand. Gets confusing though when we start getting a warm layer aloft that's above freezing and the surface remains below freezing. Depending on how thick it is, it can either be sleet, where the snow, as it falls to the atmosphere into this warm layer, melts and then refreezes before hitting the ground into these tiny ice pellets or sleet. If that warm layer is thick enough and the surface remains below freezing, then that snow melts through this thick area of above freezing air, but doesn't have a chance to refreeze into snow or ice pellets before hitting the ground. And this is what causes freezing rain. I have a pretty easy to understand graphic showing that and how the depth of warm air aloft impacts your precipitation type. But what about this sounding here? So this is taken from November of 2013, just from Anchorage. The entire sounding's below freezing, right? So if it was precipitating during this time, we would expect it to be all snow. In fact, it was not. This was actually a freezing drizzle event that glazed over the roads of Anchorage with about 1,600 inch of ice across the roads and caused a lot of issues. So how did this happen? If the entire column of air is below freezing, how can freezing drizzle or liquid precipitation still fall out of the sky? So to understand that, we have to understand how snow forms. To do that, let's look at cloud layers in the sky and look at the temperature profiles of these cloud layers. So if a cloud layer is between 0 and about -10 degrees Celsius, that's actually going to contain mostly these supercooled liquid droplets. Even though it's below freezing, the presence of these droplets are pretty prevalent. They haven't turned into ice yet. Once you start getting below -10 degrees Celsius to about -20 degrees Celsius in the atmosphere, you're going to have a mixed phase where you're going to have both liquid droplets and ice crystals in that cloud. And then once you start getting below -20, you get progressively more and more ice crystals and less supercooled liquid water droplets to about -40, where there's almost no liquid water droplets in the atmosphere. So for snow formation, it really forms in about a couple different ways. But the thing that you have to have is ice nuclei. Ice nuclei is like, describe it as almost an impurity in the atmosphere, like a speck of dust or salt from the ocean that's suspended in the atmosphere. And water vapor, if there's enough of it, can actually form an ice crystal right onto this this nuclei in the atmosphere. And it can also do it from when supercooled droplets collide with this nuclei, and it can form ice crystals, which then begins the formation of snow. Now, as snow begins to form, it actually grows at the expense of liquid droplets in the atmosphere. So you can think of it as it cannibalizes the cloud droplets to make itself grow bigger and bigger. And this process is maximized in this area where it's mixed phase in the cloud. So you have both ice crystals and cloud droplets, and that's that -10 to -20 degree zone. It's also known as the snow growth zone or the dendritic growth zone. So these dendrites really like to form and grow efficiently in this zone. And if you have enough moisture and enough vertical motion or lift in the atmosphere, you can get really efficient snow growth in this area. And that's what we look for when we're forecasting snow. So here's an example. This is actually from yesterday. So everyone was aware that lives in Anchorage. We got an awesome snow event yesterday. And this is the profile from yesterday morning, right in the middle of the event. And here's the overlay of the snow growth zone, and then the zone where we would expect to see mostly liquid droplets in the atmosphere. And what you notice here is the vertical profile, temperature and dew point, is completely saturated in the snow growth zone. So there's a lot of ice crystals forming and snow forming here. Now in this layer where there would be liquid droplets, well, as the snow begins to form above it and it falls through the supercooled liquid droplet zone, it actually changes those liquid droplets into snow. So liquid goes away and it's all snow, and that's what we saw. And the reason why our snow yesterday was so low density is because we had such good dendrite growth in this snow growth zone. This is a classic snow growth example of an upper air sounding here. But what happens when there is no moisture in the snow growth zone? Well, in this example, this is a classic freezing drizzle sounding. You notice here the snow growth zone is almost completely dry. So there's likely no ice crystals in here. That means If we are saturated down lower, we have like a shallow cloud layer that's below freezing, but warmer than -10 degrees Celsius. These are going to remain liquid. We're not going to have any snow forming here that's going to fall through this area and turn these droplets into snow. And that's how freezing drizzle forms. So in this area, in this sounding, this is likely all liquid droplets, and there's no ice crystals left in this area. So if we go back to February 27th in the morning at 4 a.m., when the freezing drizzle was falling across the Hatcher Pass area, we look at temperatures across the region. So this is the bottom of the canyon. They range from about -2 degrees Celsius all the way up to the top of Marmot, about -7 degrees Celsius. So that's right in the middle of that area where we would expect to find liquid droplets. And this is relative humidity at the same time. So you can see it almost completely saturated. Well, we don't know what's going on above this area, what's going on in the snow growth zone. Well, we don't have a sounding for, over the Talkeetnas, but we can look at the Anchorage sounding at the same time. So what we see here is the entire sounding still below freezing, but we notice in the snow growth zone, we see drying air coming in aloft, and that's coming down, extending down into the snow growth zone. Now over Anchorage is not very pronounced, but we can kind of extrapolate that up into the Talkeetnas. This was extending deeper into the snow growth zone. So it was likely much drier with very little ice crystals in this area. But then we look further down, and this sounding shows that it was completely saturated in this area we expect to see mostly liquid droplets. And in fact, if we overlay the height of the Talkeetna Mountains on the sounding, you can see that saturated cloud layer extended right over where Hatcher Pass is. And in fact, the Marmot Ridge temp fell right in the middle of that saturated layer. The biggest thing that I think that led to this freeze and drizzle event is going to be the wind speeds. Now, if you look over here on the right, this represents the wind speeds at height. So if you haven't read a wind barb before, the wind barbs point the direction the wind is coming from. So for example, the winds here are coming from the southwest to the northeast, and the barbs represent the speed. So here the winds are about 20 to 30 knots, and from south-southwest. Now, as I said before, Hatcher Pass really is favored during southwest flow. The thing here that's interesting is the flow wasn't too strong. It was 20 to 30 knots. So we're still having upslope flow in this layer, but it wasn't strong enough where we would get the clouds to begin to deepen into the snow growth zone. Let's say if the winds were 40 to 50 knots, we likely never would have seen freezing drizzle occur here because the clouds and the moisture would have extended up into the snow growth zone. We would have had snow formation, and then we wouldn't have had any liquid droplets present in this layer. But because the flow was just right, it was resupplying the moisture in the low levels in this shallow area, and it persisted long enough that we had several hours of freezing drizzle, which led to a pretty thick crust. If the flow was weaker, we might not have had enough forcing to precipitate out anything from the atmosphere, so it just would have been dry. But in fact, it was just in this right area that we had enough flow and forcing to lead to freezing drizzle. I looked at another event, just going back in time, trying to see if we had any other examples. I know talking with Jed and Allie, they definitely experienced these events more and more. So I found one back in February of 2019. And the observers here they reported that there was about 10 inches of snow that was capped by a thin drizzle crust everywhere. So I went back, looked at the Anchorage sounding at the same time. So we stepped through it. We can see that the snow growth zone, we're pretty saturated through here. So we expect snowfall production. Here's the height of the Talkeetnas. Still pretty saturated. So this is still a snow profile. And then we notice as we step through time, this dry air beginning to descend down into the snow growth zone, while the low levels remain saturated, but between 0 and -10 degrees Celsius. So we'd expect liquid droplets here. And then this is really obvious here, this nice inverted V sounding. This is really dry air. There's no ice crystals in here, but there's still liquid water present in this layer. So this is right where the freezing drizzle was found. Notice the flow here. It said it was a thin crust, and I'm guessing the flow was weak enough that they only got a short period of time where it actually drizzled before it completely dried out. So what can we take away from this? What are some of the conclusions? Well, freezing drizzle is really this Goldilocks scenario where you have three different things that you have to look at. They have to come into play. First, you have to have a saturated layer that's between 0 and -10. So your cloud tops have to be warmer than -10, but you still got to be below freezing. And you have to have a lot of dry air in the snow growth zone, so there's no ice crystal formation up there. And I think almost most importantly is you have to have the right amount of flow or forcing. So again, as I said, too much flow, the moisture is going to deepen into the snow growth zone and you're going to get snow forming. Too little, drying from aloft will mix down and you won't have enough moisture to really precipitate out and to lead to freezing drizzle. I also noticed that these events tend to occur at the tail end of a weaker storm system. So storms that maybe drop 6 to 12 inches of snow, and as they depart, dry air moves in aloft, but the low level stays saturated. So that's something to look out for. It doesn't happen all the time. You just have the right ingredients for this. So I guess the question is, can this be forecasted? In theory, yes, it can be. You can, if you catch this, if a forecaster catches this and looks at the right atmospheric conditions and notices it, then yeah, it can be forecasted. But the truth is, in the mountains, or not in the mountain rec forecast, you're probably not going to see this added to the remarks section, freezing drizzle. Highly unlikely. It's a very difficult situation to predict. You're more likely to see this maybe if it were to impact the Anchorage area or the road system, because it's going to have a lot more impacts than if we had freezing drizzle in the mountains. And it's just kind of the nature of the beast. But in terms of snowpack stability and avalanche danger, does forecasting this help with an avalanche forecast? And I would say that it really doesn't before the drizzle crust gets buried, because it's going to add the same amount of weight to the snowpack as if it were to fall as snow. And in fact, it's actually going to cap the snow surface. So it's going to prevent horizontal transport of snow from the wind. So it'll prevent wind slabs from potentially forming, and it will prevent dry loose avalanches from forming. But until it gets buried, there's really not a lot of impact, I would say, to the avalanche danger, instead of if it were to fall as snow. But then once that gets buried, then we're in a whole different situation. And I guess this is a good segue into Allie's talk.
Kyle, that was awesome.
That's all I got.
Thanks so much.
Turn off my screen.
There we go. That was great. I think that's such an interesting phenomenon, and thank you for taking time to put that together, the drizzle crust and how that forms and such. But yeah, perfect segue into the second part of this talk, and that's the avalanche forecaster snowpack evolution associated with this crust that Allie Barker is going to do for us. Allie is, most people know, avalanche forecaster for the Hatcher Pass Avalanche Center. I don't know if everyone knows this, but I think over 20 years now, Allie's been an avalanche professional, from guiding to teaching avalanche classes to being an avalanche forecaster. So she has a ton of experience behind her belt. She's one of the founders with Jed Workman for the Hatcher Pass Avalanche Center. And Allie, I can see you on there. You want to share your screen? And excited to dig into the snowpack part. You don't quite see your screen yet. Looks like you might be working on. There we go.
Okay. And let's go from the beginning. Let's see.
I think you almost had it. There we go. That looks perfect.
Okay, that looks good.
Yep.
All right. It's pretty awesome being able to talk about this after Kyle has explained everything so well. I feel like all I need to do is show a few pictures now. But yeah, thanks, Kyle. I think a lot of you maybe who aren't familiar with this event might be wondering, why the heck do we talk about the drizzle crust so much and who really cares? And the reason is because it was the culprit weak layer in this massive Easter avalanche cycle. And I'm going to talk a little bit about the snowpack and historical data at Hatcher Pass, the drizzle crust, weather leading up to the Easter cycle, and lessons learned from this event. So the Easter avalanche cycle occurred April 4th, 2021, as most of you remember last spring. And first thing I'm going to do is go back in history a little bit and talk about some other big avalanche cycles at Hatcher Pass, so we have something to compare this to. This was in 1967. Tom Murphy gave me this photo when he was caretaking up at the Independence Mine and Hatcher Pass Lodge. And looks like about 30 feet or more of debris in this picture that crossed the upper and the lower road. And then in April 1977, another avalanche crossed the road. This time, we're not sure how connected these were, but we know that the southwest face of Marmot, the South Ridge, and the southeast Marmot Gully 3 went. And this was kind of a funny photo because Tom Murphy's friend Sam had just gotten a new pickup truck, and even though these avalanches happened in April, the road wasn't cleared until July 4th. And in 1980, there was a storm that dropped 6 to 10 inches of graupel, which would be fun, Kyle, if you could go back and look at all the graphs and see if we can see what, look at this in 1980. But the 6 to 10 inches of graupel landed, and then a bunch of snow landed on top of that, and many avalanches occurred that crossed the upper and the lower road. And this is, at least with the historical data that we have, this is the cycle that we compare that we think is most similar to April 4th, 2021. And also the only time mitigation has occurred at Hatcher Pass prior to 2015. Tom Murphy, who sent this photo, mentioned that the wind blast was enormous and crossed the lower road, coating the trees. He associated the graupel as ball bearings that likely assisted the slab in gaining exceptional speed. So in terms of historical avalanches that we have data for, and if anyone else has more info out there, please feel free to share. But this is the list, and I know it of what we have. So again, avalanches that hit the road. That could be just the upper road or the upper and lower. And again, we're more focused on the travelable road that people are driving vehicles on, obviously, because that is what is managed by DOT. So the first avalanche we have record of is 1932, 1967, 77, 1980, again, that being the biggest one we have record of before last April, 81, 82, 86, 87. And then I think it's interesting here. So I would kind of categorize these earlier avalanches, typically during that time period and up to about the 90s, historically, we have heard that Hatcher Pass got typically 7 to 11 feet of snow. That's quite different than what we're getting now. So one of the presentations earlier made me think about how climate and our weather patterns have shifted at Hatcher Pass. And we just don't get that much snow anymore, and we're getting warmer, wetter storms. So what we're also seeing starting 2015, 18, 19, 2020, 21, not only are we seeing this transition from these large avalanches happening only in the spring to starting as early as November and having similar paths cross the road even twice during a season. So we're calling last year, 2020-21, winter of many crusts. And this is important because historically, Hatcher Pass gets cold, gets a lot of snow, has a cold period, snow, cold period, and so lots of faceting occurs in the snowpack. Even if we have a crust, it typically deteriorates and doesn't linger very long. So last winter was a bit of an anomaly with warmer, wetter storms and many buried crusts. We look at the snowpack early season. This is January last year with facets at the bottom of the pack, pretty typical. This is what we're used to. And move, let's see, to February 26th, so right before the drizzle crust event. And we already have one buried crust. And then Kyle talked about weather, so I'll skip through this. But we can just see here pretty clearly that temperatures were well below freezing for that event and made it hard to forecast for. So everyone seemed to be stumped, including the weather forecasters. And this slide isn't even meant for you to really read or comprehend it all. The idea is that to just, you see there and highlighted in red, this event is very difficult to successfully forecast for. We must have had conversations with 10 different forecasters and everyone was just scratching their head trying to figure it out. So always something we can learn. And at this point, we have 5 buried crusts in the snowpack. So again, pretty unusual, but becoming more common for Hatcher Pass. And at one point, we had 7 buried crusts in the snowpack last season, which I've never recorded 7 buried crusts. And moving into March, here are our drizzle crusts buried in the snowpack, not going away. Obviously, red flags, there are thin, weak layers, persistent grains, all the things that we are concerned about. We do forecast for persistent slab problems, probably 70 to 80% of the time at Hatcher Pass. April 3rd, one day before the historic Easter avalanche cycle. And I believe next, do you want to show the video?
You want to try it first? We'll see how it goes.
Okay.
I can share it. The spinny circle's not a good sign.
Okay. Hi, Allie Barker from the Hatcher Pass Avalanche Center. We're out here on a west aspect at 4,200 feet on Marmot Midrib, looking at the structure on this west aspect to see if there is a slab over this sun crust, drizzle crust, weak layer that we're worried about. We recently had a remotely triggered avalanche on a northwest aspect yesterday that also failed on this sun crust, drizzle crust here. And this is where the majority of the avalanches have been failing in the last 2 weeks. We're going to see what we got. I'd call that significant.
All right.
Okay, so
that was significant.
Let's see, try to get back to this next slide. So yeah, and then this is what was next. Let's see. Obviously, something to be concerned about when you have those results, stability results, instability results. We're looking at getting 24 to 30 inches of snow at Hatcher Pass, combined with 2 to 3 inches of water. And then Saturday, we put out a forecast with considerable danger. Again, this is just before the Easter storm. So already concerned about instabilities in the snowpack. We're anticipating danger to rise to high by Sunday. And what happens 9 a.m. Sunday morning, the forecast is updated and danger is elevated to high, accompanied with an avalanche warning. Travel in avalanche terrain is not recommended. Avoid being on or underneath all slopes. HPAC recommends at this point to DOT to close the road at Gateway and anticipates that large to very large avalanches will cross the road. And at 6 p.m., precipitation has increased and we have confirmation of large to very large avalanches that have crossed the upper and the lower road. So another day, Monday, April 5th, we have high danger day 2, and the avalanche warning expires Tuesday at 7 a.m. So what happened? It seems like we just got moderate amount of snow, a little bit of wind, a little bit of water, but really it was the combination of everything that created this historic cycle. So 11 inches of new snow and 2 inches of water. Temperatures increased throughout the storm. Winds gusted south-southwest to south-southeast to west, 20 to 41 miles an hour for 24 hours. And most significantly, Marmot Gully 1, 2, 3 and Archangel 1 ran big, D3.5, D4 plus. And again, this is a big deal because it was sitting on the widespread drizzle, facet crust combined with the intensity of precip and sweet. And now that you understand how that drizzle crust formed, you have a better idea of why this event had such a big impact. So about 2 inches of water during the storm, which isn't shown totally accurately on this, but we had about 2 inches of water, and the aftermath looked like this. And this photo is more so you get an idea of what we're talking about with the names of different paths: Archangel 1, Marmot 1, Marmot 2, Marmot 3. Lookers left on the screen is the standard Southwest Ridge Marmot up track that you kind of right around the corner that you head up from the Fishhook lot. And if you haven't seen these photos, well, you can see that many of these paths actually slid twice during the storm, and with different densities of snow, which is pretty fascinating. So Archangel 1, or Fern as some call it, crosses Archangel Trail and the upper road. And you can see this one slid twice during the storm. And this headed for the lower road, but didn't quite hit it. This is Marmot Path number 1, which crossed the upper road and almost hit the lower road. Pretty close there. And if you look out in the far right in the red circle, that is Marmot Gully 2 that crossed the lower road. Interestingly enough, some debris from Marmot Gully 1 jumped over into 2 and probably contributed to the amount of debris that then hit that lower road. Again, just showing how a lot of damage can be done in one avalanche cycle, and also the fascinating beauty and power of avalanches. I mean, this is amazing. This debris comes down and then just goes down the road, and in other photos, it goes straight up the road. So there was a dusting of snow when I took these photos, so it's a little harder to see, but there's continuous propagation up and all the way around these bowls, specifically here, Archangel 1 or the Fern Path. So you can see that, you know, these avalanches failed on that drizzle crust, but they definitely could. We had deeper, weaker layers that could have been more catastrophic. So April 7th, a few days after the large avalanche cycle, you can see the scary slab weak layer combination obviously still exists, but stability is slowly improving. And some take-home points from this storm. Buried facet crust weak layers that linger all season are a relatively new phenomena for Hatcher Pass. Widespread thin buried weak layers combined with warmer, wetter storms will produce larger avalanches, larger avalanche cycles in the future. We anticipate more warm, wet storms in the future. The paths that hit the road all have the capacity to go bigger, potentially having more of an impact. And working in conjunction with DOT and state parks is effective in sharing messaging about these events and brainstorming mitigation procedures to keep the public safe and save lives. And lastly, Hatcher Pass Center needs your donations for our up-to-date professional forecasting observations, timely social media posts, and weather updates, because we are a non-agency center that depends on you. So please go to the HPAC website and press the donate button. And I'll pass it off.
Allie, thanks so much for putting all that together. It's great to see all the photos, and I think we already have some interested people to hear a little bit more about the aftermath, and I think there'll be a bunch of questions. So thank you. We'll move to the third and final presenter on the Easter cycle, and that is Jim Kennedy. If Jim wants to turn his camera on and cue up his presentation. Jim Kennedy is currently the Avalanche Program Director for the Alaska Department of Transportation. He oversees not just the Seward Highway down in Girdwood and the Kenai Peninsula, but all the way up, as you'll hear, at Hatcher Pass. Jim also has, I think Jim may be over 40 years of avalanche experience. Jim was longtime snow safety director at Alyeska before he joined the Department of Transportation. So it's really great to have all of Jim's wisdom and history, and thank you for joining us today.
Thanks, Wendy. Can you hear me all right?
Yep, we can hear you, and now we can see you.
Oh, good. I thought I'd give everybody a brief look into DOT's perspective and how we deal with Hatcher Pass and the avalanche problems up there. And some people might say it's my twisted view of the world, but that's all right. We'll give it a shot. I think Ellie and Kyle explained these really well. I won't go into too much about these avalanche paths, what we're dealing with, but this all started for us about a week before Easter. We just didn't know it at the time when this avalanche cycle was starting. And we all know about the snowpack with multiple layers of facets, drizzle crust, sun crust, depth hoar. There was just nothing good there. And our confidence was pretty low that the snowpack could hold any kind of a load. So it was definitely on our radar, and we were paying pretty close attention to it. And we're based out of Girdwood down here. So, and our first sign or incident that came about was on the 26th of March. So some of my screen's covered up here. On the 26th of March, We got a phone call or two from folks. It was pretty amazing. Right after this happened, my colleague and friend Tim Glassett had friends of friends up there on the government peak side, and he was getting phone calls and pictures almost immediately after this event happened here in Marmot 3. This is our most frequent runner that hits the road the most, and it was skier triggered, remote. Somebody skinning up the other side. They didn't even know it happened for a while. We classified it as a soft slab artificial skier remote. D2 might have been a little bigger, but it was 3 or 4 feet deep average for 200 feet and 8 feet at the deepest spot. This was the photo that I got from one of our drivers. We just happened to have 2 plow trucks up there working the Fishhook lot and the Independence Mine lot. And normally it takes a loader to clean stuff up like this, but they thought they might be able to punch a hole through it and let people get out of there. So while we were driving up to Hatcher Pass from Girdwood, they punched a hole through it and let some folks out. And one thing that was interesting about this was there was people all over the place this day. Had we wanted to do any avalanche work, it wouldn't have been possible for a couple of reasons. Mostly there was too many people. We don't have the resources to go track everybody down and get them out of the way. So we have to assure our starting zones and run out zones are clear before we do anything. And we didn't have a helicopter available that day either. We have to use state of Alaska approved helicopter companies and nobody was available. So this is what it looked like after they punched a hole through it. You can see it's probably 8 feet deep there, but we worked through this day. Once we got there, we assessed it and most of number 3 had come out and we felt pretty good about things as long as we didn't have folks up on the ridge above the road acting as triggers. And I managed to talk to a few groups that were doing laps over on the other face of Marmot, and they were really cooperative and said they weren't going to go over there. So we felt pretty good about that the rest of the day. And what that did was that bought us a couple more days, only we just didn't know it at the time. So we move into March 29th. This was the forecast for Monday morning. And you can see we're looking at maybe just under an inch of water, 10 to 16 inches of snow with a little wind. And our confidence is still pretty low on strength of the snowpack. So this turned out being our first preventative closure. We closed the road down at 9 o'clock in the morning, got everybody out of there and let the storm do its thing. We checked conditions again on the 30th, and it turned out that, we had poor visibility, heavy snow showers, couldn't see anything. So we weren't sure if things had slid or not. So we decided to give it another 24 hours. And that also helped the plow crews down in the valley because they got snow down there and it gave them a chance to catch up. You're going to hear me talk about resources and priority levels a few times in this talk here. So we came back on the 31st. We had good visibility and we were able to get a good look around. You could see that there was some activity in Marmot 1 and Marmot 2, but there wasn't much else that we could see around. So we decided to go ahead and plow the road up. We didn't have any debris on the road and the winds were pretty calm that day. So we got trucks up there and we plowed the lots and the roads and had everything open back up again by noon. So at the time we didn't know it, but that bought us a few more days. Then we found out, or we saw this on the internet this is April 2nd, I believe, from the Ski Talk photo there. This was also skier triggered. The debris didn't make the road. We looked at it and thought it went about 80%, but it did dust the road from some folks that I talked to later. And that was telling us that it was still tender and we still needed to be on watch for everything. So we tracked the weather pretty close during this cycle, and my life revolves around weather forecasts when it's coming, and the Weather Service folks were nailing these forecasts lately, and we had weather on the way. There was a good shot at precip and winds coming to Hatcher Pass. So we knew the road was going to close again at some point on Saturday. We just wanted to nail down the timing of the storm better. We didn't want to close it too early. We certainly didn't want to close it too late. So we gathered resources and we decided on 9 o'clock that night, or 2100. We got the road all closed down at 2132. It was all clear, got everybody out and shut it down, and waited for the storm to go. And Tim Glassett came up the next morning, and this is what we found. Our closure had been vandalized, and fortunately Tim was able to fly our drone up the road and determined, and was relatively felt pretty good about it, that there was nobody up there. So we reinstated the closure and let the storm rage on. You can see difference how much new snow just from 9 o'clock that night. I'm guessing this is probably around 8:30 or 9 in the morning on Sunday morning. So anyway, Tim headed back for Girdwood and check on our southern zones down here. Just about the time he got back to Girdwood, we got the phone call from Dan and some other folks. Dan Amiot's the park ranger up there, and said the lower road got hit about 3 o'clock. And I'm thinking, well, oh, good, the lower road. Glad the upper road was closed. Probably should have closed it down lower. But anyway, we got the call, slided the lower road. Nobody involved, so got lucky on that one. But we did have 8 cars stranded in the Gold Mint lot that we needed to get out of there. So working logistics on the way up, we got a loader moving towards Hatcher Pass from the Palmer camp. And we got a closure set up just past Ski Talk. And then the loader arrived about 1740, just after I did, from Girdwood. And we punched a hole through it, and we went up and started collecting information from the stranded cars up there. We had all those guys out by 1830. But we had another problem that arose from our interviews with everybody in the cars. We still had one car in the lot and there was nobody around to drive it. And we were getting reports from reliable witnesses, folks that were stranded. They saw 2 skiers scanning up the road before the last slide took place, which we were thinking that it was probably the Fern slide. And so we were kind of wondering, looking at our watches, thinking, wow, it's been 3 hours. If somebody was involved, chances of a live recovery are pretty slim to none. So anyway, we mobilized and got Dan's snow machine out. And Tim and Dan went up the road on the snow machine to the debris and chased a few tracks around, did a beacon scuff search between the roads, and didn't find anything, didn't get a signal. So all that took place probably over an hour, hour and a half or so. We started fighting darkness, and it was still snowing and blowing up there. So the tracks clues weren't very good ones. So we weren't sure on anything. And we gave it a shot if there was somebody involved. Then we went down the road and to a good cell signal and contacted the troopers and did all the reports with those guys, because it was in their hands for possible missing persons. Sorry about that. But it turned out okay. The next day, the troopers were able to get their bird up in the air, and they contacted 2 folks coming out from the snowbird hut, and I believe they gave them a ride out. And it was all good. That solved itself. And we were able to get our UAV up in the air and just see just how big this event was. And our UAV that we got has a lot of more capability than our avalanche office drone. And I call this one the Cadillac. It's got some photogrammetry software on it. This is a shot of the lower road. The creek is on the right, lower right of the photo. And that slide did go into the creek, the Marmot 1 slide. And we were able to determine through photogrammetry that there was 2,300 feet of center line covered. on that, which is quite a bit. It averaged 6 to 8 feet deep. And the drone was telling us that it was 16 feet deep, and we measured a spot that was 22 feet on the cleanup. And it took a few equipment resources to get those plowed out. It took a D6 cat, a D3, 2 loaders, and then all the support vehicles and personnel to make that happen. And it took 4.5 days to clear everything off once we got started. And these are how we classified stuff, and we came up pretty close to what Allie did. We 3.5. There's some interpretation on the run out distances you might have a question about. Back in the day, when the folks first started setting up databases for DOT, they used the road as 100%, and their thoughts back in those days were, if it's not hitting the road, it's not an avalanche. So that's how they dealt with things back in those days. And I agree with Allie, these paths are avalanche multiple times by looking at the debris flows. And the best we can tell is 79 or 80 the last time the lower road was hit. When they were doing avalanche work for the Coronado mine up there in those early 80s, and they used an avalancher on that snowcat. So you can see here, there's multiple slides in there, the way the debris flows are going. And so folks are wondering why it took 17 days to get the road open. And hopefully I got some answers for you here. Seward Highway had its own avalanche issues, and Tim and I are an army of two. We had a road hit on the 29th at Summit Lake in the afternoon, about 4 in the afternoon. And we also, during the same time period, had 6 gun missions. We shot 75 or 80 rounds. And one interesting thing that came up by looking through our database is we had 15 out of 33 slides that were running 90 to 97%. And what that's telling me is that even between our howitzer rounds and natural avalanches, we had 15 slides that were coming really close to the road. So that's where our attention was, and that's where our resources were concentrated at. This is the Summit Lake slide on the 29th. And that guy in the pickup, brand new pickup, it just so happens he was a retired railroad worker that was on the gun crew. So he had some great comments about that whole situation, but no damage, no injuries, it was all good. And we're trying to get avalanches to come down when we want them to. And sometimes that can be tricky, and especially when the road's open. So we concentrate on the Seward Highway. That's our top priority. And Seward Highway is priority 1 and 2. And it's the lifeline to the Kenai Peninsula and Girdwood. And Hetra Pass Road is a priority 4. It's recreation road. So it's not going to get the same attention. And I'll end with this disclaimer here. The DOT does not have the resources to provide the same level of service at Hatcher Pass as we do on the Seward Highway. So any changes with regards to priority levels, management, or number of personnel will come from DOT leadership. They are aware of the situation. And if you have questions and haven't seen our webpage yet, there's a link to it right there. And there's contact info there too. If you got questions or comments, shoot us an email and we'll do our best to answer them. And Melis is going to play the video now, and thanks for your time.
And there's no audio on this, just so everybody knows. Feel free to narrate, Jim.
No, I'm looking at my note that says, watch your language.
Those are snow machine tracks, Jim, on the road there?
Correct. I believe those are from Dan and Tim.
Got it.
We did have some snow machiners come from the Willow side when it was closed too. So I don't believe those are there because this was the day after, I believe.
And is that from when they went up to search the debris piles for signal?
Right.
Got it. When you didn't know if there were two missing persons at that point that ended up being okay at the snowbird hut.
Correct.
Awesome. Let's turn my video on here. There is one quick question that I just will ask right now that I just lost it, but it had to do with how do you know, or if someone's pushed off the road in a vehicle or something in this instance when you go up there and having that confidence.
Well, I don't know if there's any confidence anytime really, but you know, we just go look. We just go look up there, and chances of, you know, we had the upper road closed, and at the lower road, the way the slide was, I don't think that would have pushed the car or vehicle down into the creek and might have rolled it over on its side. But, you know, we just go look at that stuff. And if we don't feel safe going in there, that's when we put the drone up and get some eyes in the air.
Got it. The same individual, actually, now that you mentioned the drone, do they use those ever, or yours, for SAR operations?
I don't know, Wendy. That big drone that we had is from our UAV person in Anchorage. I don't know if it's available or not.
Yeah.
I know if Tim and I are ever around, then we could certainly use our drone to help look for stuff.
If it happens to be the same incident, which can definitely happen, as we know. Luckily,
yeah.
it didn't end up being a SAR. Ralph Baldwin's asking if there's access to a daisy bell for mitigation now in South Central.
There probably is access. My personal feelings about the daisy bell is that they don't pack enough punch. And if I was responsible for forecasting a rescue scene or a recovery scene, I wouldn't feel very comfortable about putting the people underneath that by just a daisy bell. If you're going to be in the air with a helicopter, you might as well be dropping 25 or 50 pounders out and make sure that and reduce all the uncertainty that you can. Daisy Bell's a tool. The daisy bell is a tool that works with timing is everything. If you can hit the snowpack when it's at its most unstable point and right after a storm. But we found out that a lot of times the timing's way off for daisy bell for us. You know, it's the equivalent of a 2-pound charge, I understand. A hand charge, a standard hand charge that ski areas use.
And it's not at the optimal time because you need flyable weather, of course.
Correct.
To
That's
shift
my own
gears a
personal
little.
opinion.
Say that again.
That's my own personal opinion.
We'll shift gears a little bit. There was to maybe Allie, if I'm hoping you're still there, and anybody else on the panel that was there, but there's a few questions about the crust and if the avalanches were going above the crust, below the crust. And I know there was some talk of that, of course, during the cycle, but can you just explain a little bit about that? And if it was a variety, or just to clarify some of that.
Yeah, we believe that many of those paths that went twice during the same cycle, we believe that they both went above the crust. You know, we were seeing, say the week prior, we were getting results that, you know, with propagation above and below. So, but in general, with the aftermath and the flying around in a plane, what I saw was everything going on top of the crust. So we think that the first time any of those paths went was were storm slabs. And then as it warmed up and we were getting about, 0.1, 0.2 inches of water per hour, that's really where we saw that shift. And that's where we think, the wet debris came out that you clearly saw was different than the beginning of the storm.
Right. I know that obviously when the storm keeps going and the roads closed for that long, it's not like everyone can go get in the start zones and confirm things, as we know, right? So you have certain tools to go by, and crown character and bed surface. Great.
Yeah, and they definitely all look like persistent slabs, at the end, and when you're flying around and you're looking at it. And then from knowing what we saw leading up to the storm, that was also our best guess. And then digging it, lower and mid elevation where we could after the storm. And then I'll just add, there was one question about grapple being a culprit in this cycle, and the grapple that we saw was not, I didn't see it everywhere. It was kind of hit or miss. So it definitely could have been a factor in some avalanches. I don't believe that it was on the majority of these ones that hit the road.
Awesome.
Hey, Wendy, now that we have our panelists up in a few minutes, I was thinking if people in the audience wanted to raise their hand, I could probably help, and we could try to entertain some live questions too for this panel.
Okay.
I could help manage that. I'll scroll and see if anybody's raising a hand.
We'll look for a raised hand if you want to ask your question live. Mike James made a comment here for you, Jim. He says, I wonder if you were around for the 1985 freezing drizzle crust in South Central that Dave Hamry talks about that caused widespread large slides due to faceting below it. That's interesting.
Yeah, I was. It held a lot of weight. I think we had like over 1 meter of snow on it for weight at the ski area when I was there at the time. And that's when we were breaking out 100-pound sled shots and cleaning things up and got it to move. I don't remember. There was a couple years. There was 1 year in particular where we had a freezing drizzle crust and the volcanoes went off. And so we had an ash layer in there too. And it was like having a calendar in the snowpack because you knew exactly when the ash and everything came in. And it was pretty weird because it was weaker just below the rain crust with the ash was warming it up in there. And it kind of held it and capped it over. And so things were breaking below the rain crust on a lot of those, if that was the same one. But my memory isn't as good as it used to be.
That's it's really great to have these really large events or unique events documented, and we'll be clipping this portion out to keep for the Hatcher Pass Easter cycle. I think one other question just came in here.
Yeah, Christopher McIntosh, I'll unmute you and you can ask your question live.
Yeah, I'm just wondering if there's any the latest technology out there, whether it be beacons, avalanche, whatever those called, that can hopefully increase the safety of backcountry skiers. Thank you.
Yeah, does anybody want to weigh in? Do you feel like there's any technologies you use in your work or you would recommend for recreationalists to help extend their margins?
I think it's really just what we're already doing and what we can continue to do better, which is knowledge and education and practice. There's the tools we can carry with us, but unless we know how to use them, they're not going to keep us any safer. And, they can become a crutch sometimes when we have those tools and think that they're going to save us. So, I just think education and practice are the tools to to allow you to make better decisions and try to stay safe in avalanche terrain.
Thanks, Sally. Chris actually had a question similar to that earlier that we didn't get to answer. So I'm glad he was able to ask that again. And I think another piece of his question was and this would be interesting for Kyle too, any software that can help interpret snow layers or snow stability. And I know that there's a snowpack model that is pretty. Maybe you can speak to that, Kyle, for software looking at snow layers.
Yeah, the snowpack model is it's available publicly. You can download it, and the Swiss Snow and Avalanche Research Center out of Davos, they're the ones that created it. It's kind of advanced. It's tough to set up and use. So for the general recreationist, I wouldn't say it's a good tool to use. It's more for research and more operational forecasting. But understanding where to get weather data, observed weather data, especially from the avalanche centers here, is really important. That's what I would say, is look at observations, both snowpack and weather, and know what you're looking at.
Right, I think Allie kind of hit it too, as we do have a lot of good technology, but our human nature gets in the way of things a lot of the time. And that's what a lot of these workshops are kind of about. Let's see, I think, Melis, do we have another question there? No, maybe not.
I don't see a hand raised, but somebody had a documentation question for Allie. In one of your pictures of your snow pits, you had facets at the bottom labeled as chained or anchored, I think. What does this mean?
Oh, I forgot that I said they were chained. Chained facets. So there was some moisture present in there. They're connected, and there was a long column of them basically. So that means that we probably at that time, that snow grain, it faceted and then it got warm, and they, let's see, the easiest way to explain it, they basically attached to each other and then it got cold again. So they were chained together. If that makes sense.
That's another plug for taking your upper level avalanche classes. I think we're doing really great on time. Do Kyle, Ellie, or Jim have any last thoughts before we move to a little video from our sponsors? Doesn't look like it. Thanks so much for taking the time to put this together. It's really, really great to have the three of you here and dig deep into this event. So thanks again.
Thank you.
Cool. Thanks.
Thank you.
I'm going to share a couple of videos from our sponsors, and then we'll introduce Ava. So just a quick break, 2 minutes.
I think of snowbird ski patrollers kind of like surgeons. Type A people looking for excitement and thrill, but also with the accountability of a surgeon. Every day that we go out, either for routes or for a patient, someone is trusting you with their life. But there's a reason why people do this job as long as we do. We're addicts, addicted to hard work, adrenaline, and powder skiing.
All right, everyone. Melis, do you have one more, or are we good to go?
We're good to go.
Oh, super. So our next speaker is Ava Latuso, who is just another one of these awesome folks here today. willing to join us. She has a shorter presentation about an introduction to a new crowdsourcing study. And Ava, if you don't know, she works at Alaska Pacific University, and she's an associate professor there in the outdoor studies program, and teaches mountain weather, snow science. She also works with the Alaska Avalanche School as an upper level instructor for all the professional courses there. And a great researcher, snow science lover, and has done a lot of projects that have actually ended up in the International Snow Science Workshop. And so Ava, thanks so much for giving us a little idea of this new crowdsourcing study.
Okay, great. Thanks for that introduction, and I'm trying my best to do this in 10 minutes. I presented this same project at the Northwest Avalanche Center. I'm doing the same talk tomorrow at Bend, but I'm really excited that I have a chance to holler at the local Alaskans because you are my people. And first of all, I'm gonna click into the chat. I'm gonna put a message there right now because this research project that I'm doing this winter was actually inspired by an APU snow science student named Duncan Wright, who is currently researching how people decided where to go skiing last winter. So it's kind of like a retrospective study. He has a Google form that you can fill out, and that will help him to figure out how did COVID and crowding and your sense of more need for being outside factor in for your skiing last winter. And but I don't want you to get distracted. You'll stay in the chat while I'm going to talk because I have only 10 minutes. And now I'm here to persuade you to participate in my longitudinal study about where do you want to go, exploring backcountry travelers' destination choices. And we all know that Anchorage is about like the best ski town in America. The orange dots, Front Range, Hatcher Pass, and Turnagain Pass are all less than an hour away, and they all provide us very different skiing. And then if we want to travel just a little further, or maybe our budget is a little bigger, we can do a road trip to Valdez, or we can fly to Alaska Range. And these all have a little bit different flavor. So for example, if I'm looking at Front Range or Alaska Range, Front Range is like, it's like 2 hours door to door for me to go get a lap in. Or sometimes I just want to go to Alaska Range when I have like 2 weeks of time. I want to fly in. I'm going to have a totally different mindset for that kind of thing. But those are both available for me. But most of the time, us as backcountry skiers, we're looking at where are we going for a day of skiing. And so I often are like, well, am I going to go to Hatcher or am I going to go to Turnagain? And then it's not even just location-wise, am I going north or south? If I decide that I'm going to go to Turnagain Pass, now I'm starting to think about where are my actual choices there. Maybe it's a storm day and I'm just going to stick to the tin can trees. Or maybe I have really good partners and the snowpack stability is really excellent. So I have something a little more exciting like Cold Pan maybe in my run list. So the idea here is that during this winter, I'm going to really try to dive into this question of where do people go? And the first question that I have, obviously, is what are the typical factors that individuals include when they're deciding where they're going to go? So what's their destination for their travel? Secondarily, I want to know how the group comes to this conclusion. So, you know, I'm a natural, I like natural sciences, but I'm also a social scientist at heart. So psychology and social psychology is really close to my interest. So I want to know how a group decides where they're going to go together. And then the last question is there something specific about us each as individuals that affect that how we're deciding where we're going to go? So let's start off with the individual. So what kind of characteristics or personality traits cause us to choose some specific places to go skiing or riding? So, I mean, I have very varied people that I go skiing with, but they all have at least one thing in common. They have taken avalanche courses, and they have a risk tolerance level that's similar to mine when I go out with them. And they carry all the gear that's required. And depending on wherever we're going to go, if we're going to go ski something more mountainous where we need to have ropes and ice access, that's different than if we're just going to go meadow skipping. We might not need any special equipment for that. And risk tolerance, I just really want to emphasize that we all have risk tolerance that go from, careful risk takers into full-on aggressive risk takers. And then most of us are probably somewhere there in the middle. I mean, we all want to have some sort of adrenaline junkies because we want to go out and snow machine or ski in places of interest. But that is something that will set you up for what's the context of where you're going to go riding or skiing. And then I'm going to also want to look at the personalities of people. So there is this Big Five personality inventory that I'm asking people that are participating in the research to complete. And it's a pretty well used psychological inventory that looks at 5 specific traits that we all have. And they go on in this continuum. So I'm just going to explain this a little bit. And you can think about yourself or your backcountry partner and think about where you would go in this scale. So we start off with agreeableness. So some people are super friendly. Some people are like less attached to others. So we are all somewhere in this spectrum of agreeableness. The next one is conscientiousness. So some people are kind of always thinking things through. They're really organized, efficient. And some people are a little more like, well, I'm spontaneous and I'm easygoing. So we all fit again somewhere in there in that line. Next one is extroversion. So some people are really outgoing and energetic. Some people are more shy and reserved and might be really into spending more time on their own. Next one is emotional sensitivity. So some of us are more sensitive in all kinds of emotions we're feeling. That might make them also more nervous. And some people seem to be pretty stable. They're secure and confident, regardless of whatever is going on outside or inside of themselves. And then last part is openness. Some people are really inventive. They're curious for new experiences. And some people are more cautious and they just like more consistency in their life. And you can probably put yourself in all these lines. Okay, so then my next question has to do about the group. So how does the group come to a conclusion and why is group important? Well, hopefully many of you do not do too much solo travel. So we want to go have a safety margin of the group. But now I just told you that we all have these specific risk tolerances and we have different personality traits. And now when you put the group of individuals together, that becomes like a really interesting experiment. And there are so many dynamics playing into that. And so I found in literature this framework that looks at the small group decision-making with 3 different lenses. So some people are really schema-oriented, some people are constructivists, and some groups work more in the social influence orientation. And don't worry about that. I'm going to explain what's going on here in the next slides. So schema orientation is actually something that we teach a lot in the avalanche education. For example, Travis's story about how to use the daily flow, that's exactly it. So groups that are operating in the schema orientation are really looking at like the process of how to come to make a decision. And that's what they're trying to stick with. Groups that are constructivists, they're actually looking at who is making up the group and how that group is putting a full picture together. So they're constructing this shared mental model all the time while they're working. And this is really common in professional avalanche teams. They're seeking this communication pattern where they're creating this sense of what's going on together. And then we have also this social influence orientation, where we are looking at actually how the individuals in the group are influencing others when they're interacting with each other. And some of the things that we do in groups, all of us, we know that we are seeking conformity, which means that we want to belong. So we are trying to look at ways how we can fit in, and we like to go out with people who are similar to us, and kind of thing. And another thing is compliance. So it means that you want to follow the standards of that group. So for example, for me, it's like a no-brainer that I only go with people who know how to do avalanche rescue. That's kind of like a standard that I want people to comply with. But there is this thing that if we have a little bit of diversity in the group, it actually makes the group improve. So that's like working against the conformity of the group. And what comes with diversity and conformity together is some people are very good at persuasion. They can persuade other people to do whatever they want. And some groups, on the other hand, are really good into seeking compromise. So where everybody's voice are heard. So I'm kind of interested in how does this work in small groups of backcountry skiers and riders. Okay, and then the last, a really interesting question, right, is like, what are the factors that contribute when you're actually deciding, when you're choosing to go somewhere? And I have identified 16 factors that come to play when I'm thinking about where I'm going skiing. And so these are some of the questions in the research questionnaire. So for example, I went touring this morning. I actually saw some of the people in the audience there when I went out, and I went to Peak 4. And the reason why I went to Peak 4 is because the tour fit my time restraint. I only had like few hours of time. So it was not like I was going to drive to Hatcher Pass to check out how much new snow they got there. And obviously anticipated snow quota was really high for me to get myself out in the morning before I had to come to this conference. So what I want you to do, this is a picture from this morning, by the way. So where do you want to go? I want you to tell me. So what it means that I'm currently looking for participants in South Central Alaska, Southeast Alaska, in Washington and Oregon. And we also have a study going on in Finland, which is my home country. And we're just going to get like a robust set of participants that can tell us where they want to go. And if you are willing to participate in this, the part A is kind of like you do this once at the beginning. We're going to collect some demographic information about you. And then we want you to fill out the Big 5 personality questionnaire and share your information on that. And then after you've participated in done the part A, you will fill out part B weekly for 2 months. And I understand that's a lot of us. It's about 100 minutes of your time over 2 months period of time. But this would be really helpful for us to really create a good baseline of why do people decide to go wherever they want to go. And in this part B questionnaire that we're trying to you to fill out every week, we're asking things like, did you go out? If you went, where did you go? Who did you go with? How did you decide where you went? And why did you decide to go where you went? So, So if you are interested, I think I went over, sorry. If you're interested, here is the link to my research. It's going to launch out in January. And then, so if you fill out this form, I'll get your contact information, and then I can send you more information when the study starts in January. So if you click on this QR or go into this link, I think Melis is going to put it in the chat as well, then you can participate in this, make us learn more. And I apologize going a little over.
Oops, I missed my mute button. No worries, Ava. Thank you so much. Maybe watch the chat in there if anyone has any questions. And we're going to move to our next speaker just after Melis shows another short video from one of our sponsors. Thanks, Melis. We'll get moving and make sure it's really helpful if people chip into these surveys and these projects. So I encourage everybody to participate in Ava's work that she's doing. Next, we have another research scientist who comes from Fairbanks. His name's Gabe Wolken. And Gabe has a lot of titles here. And he is a research professor at Alaska Climate Adaptation Science Center at University of Alaska Fairbanks. He's also has a joint appointment as the manager for the Climate and Cryosphere Hazards Program at the Alaska Division of Geological and Geophysical Surveys. Lots of big words there, Gabe. And if you want to turn on your video, Gabe, and cue up your talk, Gabe is going to talk to us about operational developments with community snow observations. And he's spoken at the workshop before, and looking forward to hear where the community snow observations is these days.
Great. Okay, can you see the slide okay then?
Yep, looks good.
Great, okay. Well, hey, everyone, thanks very much for having me. Just from the beginning, our Community Snow Observations Project has been co-producing science with the outdoor community, and we have been motivated by the idea that scientists, snow professionals, and snow enthusiasts could just work together to improve our understanding of snow in the mountains. And, you know, before I launch into this, I just want to make sure that I acknowledge the CSO team. It's really a pleasure to work with such a dedicated group of selfless individuals. And I'm here to present some of the work, some of the results from this group's effort. A special thanks has to go to David Hill and Nina Aragon from Oregon State University, who have led the development of the mountainsnow.org and the snow modeling you will see toward the end of this presentation. Additionally, our project ambassadors are mountain guides, professional athletes, snow scientists, educators, and backcountry enthusiasts generally. These fantastic people all help to support, advertise, and improve the project and to educate the public about CSO, snow science, snow safety, and water resources. So thanks very much. So despite the importance of seasonal snow, the distribution of mountain snow is really not well understood. And especially in high elevation and complex terrains. So this is largely due to the challenge of acquiring snow. And this acquiring snow measurements in these locations is just incredibly challenging sometimes. But improving our understanding of the snow distribution in these areas is one of the reasons CSO was founded. So there are three primary ways in which we can get information about snow distribution. We can directly measure the snow. We can remotely sense it from different platforms, and we can use snow models to estimate different properties of snow. So we can manually measure snow. Most people are familiar with this, and this can be done as a team or as an individual. And while manual measurements are less frequent in time, they can be done anywhere. And if you're interested in snow water equivalents, or SWE, you can use a coring device such as a federal sampler to extract the snow and weigh it. SWE is just the depth of water you would get if you melted the entire depth of snow that you sample. Remote measurements of snow can be done with automatic weather stations using ultrasonic or laser rangefinders. These are fixed locations, and the measurements can be repeated continuously to create time series of snow depth information at a single location, but they don't move around. Fortunately, the National Resources Conservation Service, or NRCS, maintains a large network of remote measuring snow telemetry sites and continuously monitoring snow depth and water equivalents at these sites with automatic stations, and they're provided in near real time. However, if you look at the map here and look toward Alaska, you can see that the network of stations is sparsely distributed. Another issue is that most of the snowtail sites are at low to moderate elevations, and in areas of gentle terrain. So this is often due to the need for easy access for the purpose of either installing or maintaining the equipment. And in between these locations, there is a lot of high elevation and complex terrain. So in other words, most of the snow is in these locations where we're not measuring it. So to help fill in the gaps, spatially anyway, remote measurements can be made with mobile platforms such as planes, drones, or satellites. By utilizing the approach that these offer, we can create a map of snow depth over a large part of the landscape, including in complex terrains, such as shown here in Turnagain Pass from a LiDAR survey. This is equivalent to probing for snow depth billions of times in this area of interest. So the downside to this method, though, is that currently it can only be done in specific, reasonably sized areas of interest, and only occasionally because of the high cost and the lengthy processing times that we have. So snow models can also help fill in the gaps, and this works over space and time between measurements. So this is an image of SWE yesterday, in fact, as estimated by the Snow Data Assimilation System, or SNODAS. So the SNODAS products are available at about a 1 kilometer spatial scale for the lower 48 and southern Canada, and on a daily time step. Unfortunately, SNODAS is still fairly coarse for mountain snow interests, and it's not available in Alaska. The Community Snow Observations Project was started in 2017 with the goal of filling in these gaps and developing a global network of citizen scientists who could collect and submit measurements of snow depth. While anyone can participate, the project has prioritized participation by backcountry recreationists and snow professionals, since they frequent the places we need, high elevation regions and complex terrain where there are few measurements. All right, so participants only need a few things. And to do a few things, first, you have to go into the backcountry. That's easy. Second, you have to measure the snow depth using some device. And third, you need to submit the snow depth measurements via the Mountain Hub app, which is available in iOS and Android. And this geolocates the submissions, and the participants will see their snow depth measurements in the app or at Community Snow Observations. You can also add your snow depth measurements through SnowPilot on a desktop platform. Okay, so what do we do with the data? Well, we use a physically based snowpack model that is driven by weather data, terrain, and land cover information. We calibrate this model using high quality data from SNOWTEL and other snow course sites. And then we assimilate in the participant observations from CSO observations. And they come in through the snow throughout the snow season. So when we get a measurement, if it disagrees with the model prediction at that location and time, an adjustment is made so that the model can try to steer it back into place. A simple example of this is shown at the left. SWE is on the left axis and date is on the bottom axis. The dark blue line shows the calibration run with no assimilation of data. The presence of a single observation from the Community Snow Observation scientist, the red dot here, will drag the simulation towards the ground truth. At the right, you'll see an example of the model output for a single year in the mountains east of Salt Lake City. Early season dustings are evident, along with strong growth during the winter, and then the eventual melt out in late spring. CSO observations are really unique in that they provide a source of in situ data in complex terrain where we typically lack observations from the automated stations. In this image, we're looking at Teton Pass. And there is one SNOWTEL station in this area, and it's indicated in blue. The CSO observations are indicated by the red markers. One big takeaway here is that the places that are fun to ski are generally places where we need data. This animation shows the difference between the SWE modeled with assimilation and the SWE modeled without assimilation. The green shows where the assimilation increases SWE from the baseline run without data assimilation, and the brown shows where SWE is decreased. So get this going here. Note that there's variability across the landscape in both space and time. During the middle of the winter, there's a lot of green, indicating that the assimilation is deepening the snowpack where the observations have been submitted. In the early summer, the picture is more of the opposite, showing that the assimilation is making the snowpack more shallow, but it's helping to retain the snowpack on the high northerly aspect slopes. The results of these experiments have informed our data assimilation scheme for our operational product, which we just launched, mountainsnow.org. We're really excited about this launch. It's near real-time web application because it's something that our participants have been asking for. Let me get back to that slide. It's something our participants have been asking for from the first day we started CSO. So you wanted to know how much snow there is, and we want to tell you. So let's have a look at it. The homepage for mountainsnow.org is here. If you look at the upper right-hand corner, you'll see some links that are incredibly helpful and provide some useful information about getting going. On the map, you can see each of our current modeling domains in these boxes. And there we go. And the black boxes in the map. CSO will continue to add new model areas where snow observation activity is high. So to get your area on the map, literally, get some friends, go out into the snow and use the Mountain Hub app or Snow Pilot to submit snow depth measurements to CSO. Okay, let's zoom out to Utah.
Hey, Gabe,
zoom
we just
into the
have
Utah.
about a minute left. Just a little warning there.
Thanks, Wendy. Okay, so just showing you some of the features here really quick. As with all Google, you have your choices for map, satellite, and terrain. And the bar in the upper levels shows the layers in the map. You can choose your date on the right-hand side, and there's a slider, and you can click back to various times in the past, back to about October 1st, 2020, when we started archiving results. Here's a comparison of CSO to SNODAS, and you can see that SNODAS is having a hard time resolving the mountains in this area. You can check out the sliders to adjust the scale that you want to look at. And you can also view some of the other snow products that are available that we provide on the site. Lastly, you can look at the 72-hour snowfall. That can be helpful for a lot of different things that you might be interested in. It helps us model snow avalanches. As we talked about before, you can look at how your observations are directly impacting the model by checking out this differencing of the model runs. Thank you sincerely for your snow measurements. You're helping us out. You're helping out your fellow snow people. And we're getting to know more about the mountain snow that you're playing in. Thank you.
Thanks so much, Gabe. And again, that's amazing to see that one observation can make such a big difference. So hopefully this will get more folks, including myself, getting you that information. Let's see. Looks like Melis, if you have any questions for Gabe, stick them in the chat because we need to move on. But Melis, it looks like you put a poll up there.
Yeah, I'd meant to do it earlier. I thought I'd get a good snapshot of who's in the audience. I have everybody's names, but it's good to know how people interact with terrain, avalanche terrain. So I'll publish the results right when you're done introducing the next speaker.
Excellent. Well, this will be, before we do our little Avalanche Center updates, this is our last presentation, and very fitting, it is the winter weather outlook for this winter, and also some changes to the National Weather Service avalanche weather guidance. And providing those for us is Carson Jones. Carson is a meteorologist, an operational weather forecaster at the National Weather Service here in Anchorage. He's also the avalanche focal point for us and all the other avalanche partners in South Central. And he knows a lot about ENSO, El Nino, La Nina, snow climates. He's a big skier. He submits observations to his local avalanche center. Thank you, Carson, for being not only a computer geek, but also a geek out there in the snow. And if you want to queue up your presentation and turn on your video, let's hear about the winter weather outlook.
Right. Can everyone see the presentation?
We see you, and you just need to go into presentation mode.
Is it sharing now?
And then it's still in, it's not quite in the slideshow mode. There we go. Now
All
we
right.
got it.
Thank you. All right. Thank you for the introduction, Wendy. So I will be talking about a winter weather outlook for this season, as well as some of the changes that you may or may not have noticed to the way that we do our avalanche weather guidance or forecast products for this upcoming winter. So a quick look at last year from the CPC or Climate Prediction Center's forecast. We had anywhere from a 33 to 50% chance of it being drier than normal, as well as a very similar chance of it being colder than normal. So how did this work out? Little off from what CPC was talking, but we saw wetter conditions for the Kenai and overall average precipitation totals there in the left from the mainland of South Central. And then on the right, we had above normal temperatures for the vast majority of southern Alaska, at least for the December through February timeframe. We did stay anomalously cold through April, so maybe our cold weather just was a little bit delayed last year. Looking at some of our common recreation zones that we like to go ski or snowboard in. Turnagain Pass had a little bit above average temperatures with precip right around normal to slightly below normal, and Peak Sui right at normal. Mount Alyeska had a very similar scenario of slightly above normal temperatures, precipitation a little bit below normal, and then Peak Sui also kind of right on par with normal conditions. Hatcher Pass was the only area to really have slightly below normal temperatures. Precipitation was almost exactly normal, and Peak Sui was slightly above normal. And then Thompson Pass in Valdez was the warmest of all of our common areas here, with almost 3 degrees Fahrenheit above normal temperatures. Precip was just around normal to slightly below, and then Sui was right around normal. So overall, throughout South Central, at least our ski areas, pretty normal, slightly above temperatures, but overall precip and Sui was right around normal. So looking at an outlook for this winter, I'm going to look at the El Nino Southern Oscillation, also known as ENSO, the Pacific Decadal Oscillation, or PDO, as well as current sea surface temperatures and sea ice. These 3 metrics give us a pretty reasonable look at what we might expect in the long duration forecast or long wave patterns throughout our winter season. So first, what is ENSO? There's 2 phases to this, the La Nina and the El Nino, where the La Nina is an enhanced easterly trade wind in the eastern equatorial Pacific, which results in below average sea surface temperatures from Central America, Southern America on west there. And then you also have the El Nino phenomenon, where you have weakened or reversed trade winds, which results in the pooling of the warmer water off the coast of Central South America and even up into parts of North America as well. And both of these have been proven with a certain degree of certainty or correlation to winter weather patterns throughout the United States. Most of the precipitation correlations fall more for the southern states, whereas as you can see in Alaska, it's more just temperature. So in a La Nina pattern, you have below average temperatures with a variable polar jet stream and a blocking high pressure system somewhere in the North Pacific. And then for the El Nino pattern, you have much warmer temperatures, extended Pacific jet stream, also known as the subtropical jet, and a low pressure system over the North Pacific. So what are we looking at this year? Well, as of mid-October, we are in a La Nina advisory, and you can see the graphic on the left there, those blue cold sea surface temperatures in the equatorial Pacific there. So we are expected to, at some point here, be declared into a La Nina advisory. So looking at the chart on the right there, lots of numbers. Blue correlates with the cold phase or the La Nina. Anything below a 3-month average of negative 0.5 degrees departure from normal is considered to be a La Nina, and then the red temperatures above 0.5 departure would be an El Nino. So looking at 2021 here, last winter we had a weak to moderate La Nina for the wintertime months, and then kind of moving into fall here, our August, September, October, we've moved to negative 0.7. For them to declare a La Nina and El Nino, it needs to be 3 consecutive periods of being below that 0.5. So that's why that's not shaded blue yet. But what's interesting about this, and one of our climate focal points in the office pointed out that there's a lot of similarities in some of these long-term climate correlations to the winter of 2011 and 2012, where we had a moderate La Nina that weakened during the summer months, as it typically does, and then went right back into a moderate La Nina. That winter had, for a La Nina year, pretty high snowpack. I've heard stories of the 2011-2012 winter as being pretty awesome for skiing conditions. So just looking at INSO, that is a year that we're kind of looking at for a similarity there. Another thing here is this is a scatter plot of the forecasted La Nina strengths. So we have a week being considered negative 0.5 to negative 1, with a lot of the model clusters kind of falling into that weak La Nina area, but there are quite a few models as well in the moderate area of the La Nina there. So this winter, we're expecting anywhere from weak to moderate strength of La Nina. So what does this really mean for Alaska? Highlighting kind of 2 things is the influence of this blocking high pressure system, and then how that influences our variable polar jet. So with our changing climates, the influence of this blocking high has become more pronounced, especially in the summer and fall months, with the high really extending well into the polar regions. A week ago, or 2 weeks ago now, with our atmospheric river event, this high extended all the way from 30 degrees north latitude up north into the Arctic Ocean. So our patterns are becoming more pronounced with time, especially in the early winter timeframes. So this blocking high really kind of helps moderate whether or not we'll be cold or warm. And how that does that is when that shifts anywhere to the east, we expect it to be warmer and wetter. And that's because if it shifts to the east, then the polar jet stream will be out of the southwest for our area, which is a result of warmer temperatures. It's pulling water from the Pacific Ocean, leading to overall warmer and wetter conditions. The flip side to this is that if this blocking high were to move farther to the west or northwest, that's going to shift our polar jet stream to be out of the northwest, where the source air is from the Bering Sea, Siberia, and the interior, which we can associate pretty well with being cold and dry air masses. So it's really throughout our season, we're going to be watching where this blocking high sets up and how that influences the polar jet. And looking for a seasonal outlook, it's very hard to pinpoint where the high will be most likely. But this picture here, kind of the El Nino is kind of the mean position for that, where high correlation to colder temperatures and then not as much of a correlation to precipitation. Another one we're going to look at here is the Pacific Decadal Oscillation. It's very similar in a lot of ways to ENSO, but it's focusing on an area farther north in the Pacific, the North Pacific Basin, where we have a cold phase, also known as the negative PDO, where the sea surface temperatures are below average along the coast of North America, and the warm phase of the PDO, where the sea surface temperatures are above average along the coast of North America. So we are forecast to go into a very strongly negative PDO, which, looking at past years, the 2011-2012 year also had a very negative PDO, and that's highly correlated with below average temperatures for Alaska. So talking about correlations with the PDO and temperature and precipitation, on the left, we have the correlations to temperature. Focusing in on Alaska, you can see those dark red coloring, and the R value, which is a correlation coefficient there, ranges from 0.6 to 0.75, which in meteorology is very high correlation just due to the internal variability within our weather patterns. So we can say with moderate confidence that we will be below average temperature, or at least colder than recent decades. It's hard to be below average when the climate is constantly changing in a warmer direction. But moving on to precipitation as well, we can see really poor correlations between the PDO and precipitation. So 0 to 0.3 is basically no correlations. So we really don't have very high confidence in any sort of precipitation forecast looking at the PDO alone. Looking at our current sea surface temperatures, our state climatologists pointed out that the October SSTs were below normal for both the Bering Sea and the Gulf of Alaska, and they're some of the coldest ones actually since 1975, which is pretty astronomical, I suppose, in a changing climate world here. But why is this important? Well, the source air region for all of our storms and the source of the moisture comes from either the Bering Sea or it comes from the Gulf of Alaska. So if the sea surface temperatures are below average, then that means we can have a higher degree of confidence that most of our snowstorms for this winter will go down to sea level rather than having rain on snow into those winter months. So colder sea surface temperatures means colder precipitation types, fluffier snow. Another thing to look at is current sea ice conditions. So on the left, we have this time last year and this time this year on the right there. You can see a lot more ice in the Chukchi Sea and along the coast of Alaska, of Western Alaska there in comparison to 2020. So similar to looking at the sea surface temperatures, that being the source of our cold air, we can expect it, if the sea ice doesn't decay rapidly for some reason, that it will be colder than recent years. So what does CPC have? They're looking at a lot of the same things that I just discussed here. So they are thinking very similar to last year of a 33 to 50% chance of it being colder than normal, and then a similar forecast for it being drier than normal. So with what we discussed, I think we can say with moderate to high confidence in those correlations that it will be colder, with lower confidence on any sort of precipitation above or below normal. So in summary here, all of our climate indices kind of point towards a colder than average winter, or at least colder than recent years, with a moderate correlation to the La Nina and a strong correlation to the negative PDO. And then normal to below normal precipitation. But these again are low correlations for both the La Nina and the negative PDO. Our below normal SSTs, we can say hopefully that snow will go down to sea level here. And looking at similarities to past years, looking at these climate indices, very similar to what we observed in 2011 and 2012. So now shifting gears here, a little bit. We are in an experimental phase that the Weather Service is doing for a new product called the Avalanche Weather Guidance, with the goal being to standardize the way that the weather forecast offices produce avalanche weather forecasts throughout the United States. So it's a 48-hour product or 2-day forecast with weather variables every 6 hours for that time period. And it allows us to add more areas as well as increase our elevational resolution of the forecast. And then it includes variables of cloud cover, temperature, wind speed, direction, and gusts, probability of precipitation, precipitation type, 12-hour quantitative precipitation forecast. So that's also abbreviated QPF, or you can think of it as the liquid equivalent of the precipitation, and then also the snow level. So here's our look at kind of our current areas that we do our recreational forecast, or the rec forecast. Thompson Pass going from east of Valdez up through the pass, the eastern Turnagain Arm area, which is a huge zone, including mountains surrounding Girdwood and Alyeska Resort, Portage Valley, Turnagain Pass, and Grandview. Also have Hatcher Pass, and then this year we added in Cordova. So here, I'm going to talk about some of our new areas and some of the elevational zones that we're able to now capture with this newer product. So Thompson Pass's area has been greatly expanded to kind of capture all 3 of their climate regimes, and then also elevation zones ranging from 500 feet up to 4,000 feet, and then one including kind of the continental area where we're expecting the snow to be a little drier. And then Girdwood has been separated out from the eastern Turnagain Arm zone to focus just on the areas north of Turnagain Arm there, Alyeska Resort up north into the glaciated parts north of Girdwood. Turnagain Pass and Summit Lake here. Summit Lake is a new addition to our forecast products. Turnagain Pass and Summit Lake both have 3 different elevational zones kind of correlating with tree line, the inner mountain area, and then the alpine as well. And then Hatcher Pass was expanded slightly in hope that we can better capture some of the warm events that Kyle and Hatcher Pass Avalanche team talked about there, and then also adding in Cordova this year. And last but not least, these areas are to help with very common avalanche paths interacting with road and railways. So Grandview there on the left, the eastern Kenai Lake slide paths there in the middle, and then Portage as well. So here's a kind of a side-by-side comparison of what the 2 products look like, where a lot of you are probably used to seeing the product on the left there, which is the recreation forecast. And this is from day 1 of our atmospheric river event from 2 weeks ago. So one thing that we always get comments on is our snow amounts and the huge range in snow amounts that we have, especially in the eastern Turnagain Arm area. And the reason that this happens is because it's such a large area, and it might be raining in Portage Pass or in Portage, while the rest of the areas above, say, 3,500 feet are getting smacked with inches per hour of snow. So in comparison to the avalanche weather guidance on the right-hand side, we have our Girdwood area from 1,500 to 3,000 feet. You can see QPF is pretty high and the 12-hour snow is low. So that tells us that we're getting a lot of mixing with rain, or the snow is falling into a warmer area and melting and not really able to accumulate very much. Whereas if we look at the above 4,500 feet area there, you can see on the 3rd period there, 40.6 inches of snow. That is where our heavy snow amounts are coming from that you see in the rec. It's from these high elevation glaciated areas that do receive the tremendous snowfall rates and a lot of snow every year. So it's a very busy product. It's a lot of numbers. So how do we read this? First, you want to look at time. So it's every 6 hours, and it will either start at 6 a.m. or at 6 p.m. So this case here is the afternoon product, which we issue between 2 and 4 p.m. So it starts at 6 p.m. there and goes every 6 hours for a 48-hour period in both military and more conventional 12-hour times. Next, cloud cover. available both in a 2-letter acronym for overcast, broken, scattered, few, or clear, and then as well as a percentage of the sky cover that's being covered by the cloud cover. And then temperature. So temperature correlates to what in our times here. So looking at the column on the left, 6 p.m. temperature is expected to be 23 degrees. And then the max temp below that was 25. So when we're looking at our min and max temps, that'll be at the 6 a.m. or 6 p.m. time frame. And typically, barring some warm or cold air mass moving in, your lows can be found at 6 a.m. column and your highs can be found at the 6 p.m. column. Next is the wind direction, speed, and gusts. So direction is a 1 or 2-letter abbreviation, and that is the direction that the wind is coming from. So in this case, it's southeast or east throughout the whole forecast period, and that means the wind is blowing from the southeast to the northwest or to the west. And then our wind speed and miles per hour and gusts. Gusts will only show up on here if they are expected to be 15 miles per hour greater than the sustained wind speed. Then we have our probability of precipitation. So the chance of precipitation during that 6-hour time period, as well as precipitation type. Now, the way that the precipitation type is displayed is a little tricky. So say you're in the Turnagain Arms zone from 500 to 1500 feet. And the north part of it is expected to stay snow at 100% chance of probability of precipitation. And the southern half of it is expected rain with 100% chance of precipitation. The algorithm that displays here will always favor snow. So there will be times where you might notice that the snow level and temperature might not necessarily agree with the precipitation type. And that's why. It's because there is a little bit of a bias in the precipitation type towards it being colder. So I would recommend using temperature and snow level for your precipitation type forecasting. And then we have our 12-hour QPF, which is from 6 a.m. to 6 p.m. or 6 p.m. to 6 a.m. So daytime, nighttime. And the same goes for our 12-hour snow accumulation. And then lastly, our snow level to the nearest 1,000 feet there. So 1.8 meaning 1,800 feet. So where can I find this information? It is on our web pages, which I will show you an example of the one being developed or that is currently active in the Salt Lake City office. Ours is still being developed, but it will be hopefully overall an improvement to our current forecast here. So here's our typical National Weather Service page here. This is again for the Salt Lake City office. So you'll have a nice map here where you can pull up all of the different areas for the avalanche weather guidance forecast. So we will do maybe Alta Snowbird. And you can see our tabular forecast, which I just went over. The Salt Lake office chose to do a 3-hour instead of a 6-hour, but we all kind of agreed amongst the partners and the office that there's a lot of information in here. So we opted to do a 6-hour. But what's really nice about this new web page too, it will be this graphical forecast. So if you don't want to read all of the numbers, you will be able to look at a nice chart here instead, where we have temperature at the top, snow level, the green line below that, wind speed and direction as the purple pink line here, and then the 12-hour liquid forecast and the 12-hour snow forecast. And then if you mouse over any time period, it will give you the readout for those values as well. So with that, I will take any questions.
Carson, that was great. You have several questions in the chat that hopefully you can answer. But especially regarding the Southeast folks with like similar products. So I'll let you answer that in the chat. And we did have one live question from Paul. If he's there, you got 5 seconds. Paul? And if he's not there, we will,
Sorry, Wendy.
Oh, you are there. Great.
I'm just happy to hear that 2011 is coming around. 2011-12 is coming around again 10 years later.
That's what we're hoping
Love the
for.
product, Carson. It's going to be so helpful to add Summit Pass. Thank you so much.
Great. Yep. Yeah, I'm really excited for the potential of this.
We're excited too. And I know people are going to remember what you said and had written down there about the 11-12 year, because
I know.
we would really love to have another year like that. And even another year like last year would be phenomenal.
Right. Yep.
Yeah.
We're set up pretty well from both our September storm and the atmospheric river. So hopefully we can just keep going with that.
Well, we know who to call if things go otherwise. No, I'm just joking.
Yep.
Well, that was excellent. Yeah, we'd love to hear some of your other answers there in the chat. So thanks for staying on a little bit and answering those questions. We will move to the last part of the workshop. And if I could get, hopefully Jed's on with Hatcher Pass, Gareth with Valdez, Hoots with Cordova, Jeff with Haynes, and Mike with the Coastal Alaska Avalanche Center out of Juneau. So there, and then I myself am representing the Chugach National Forest. But if we could all put our cameras on, and we'll kind of see how Zoom does this. But I wanted to close out the workshop with a little update from all of our avalanche centers here in Alaska. And do we have Jed or not quite?
I'm here.
Oh, there you are. Sorry, I'm scrolling around all the faces.
That's fine.
Jed, can we start with you? Can you introduce yourself and let us hear what's up with Hatcher Pass Avalanche Center this year?
Sure, thanks for including us here. My name is Jed Workman, and I'm the director and one of 3 forecasters for Hatcher Pass Avalanche Center. There's also Allie Barker and Jacob Kais, who's somewhat new to our program, but a fabulous addition. And things that are new this year, we've been having our regular Saturday full forecast, and we've had a condition summary for a little while now that you're probably familiar with on Thursday. And that is transitioned to a full-on forecast. So we're no longer doing a conditions summary, but there'll be 2 forecasts a week, and that includes the danger rating. Those come out at 7 a.m. both on Thursday morning and Saturday. We are doing about 8 avalanche awareness events through Wasilla and Palmer high schools. We're really trying to reach out to the youngsters and get this information into their fingertips early on. Those have been really successful, and we'll probably see some growth there. There's been a lot of good reception from the schools. You may notice a new cam at the Marmot Snow Stake, which is a partnership between the Chugach Avalanche Center and ourselves. That is a high definition new camera. And we just purchased a second high definition new camera that we will most likely mount up at the Marmot weather station at 4,500 feet, which will give us a much better view of the weather that's coming in. And we may be moving in more directions with weather cams. For weather stations, also notice that the DOT just installed a new weather station. That's an RWIS station. And typically those are focused on the pavement, but this one has a nice view with their camera right down the firing line of those Marmot avalanche paths that we were just spending so much time talking about, as well as a bunch of good weather data. And I believe that that's showing current information, but I'm sure in the future we'll be able to draw down some historical. But it's a great addition to the weather stations at Hatcher Pass, so make sure to check that out. We purchased a new vehicle. It's actually a used vehicle, but it's fairly new. You'll see us zooming around. It's a little Toyota RAV4 that's white. It's got a little logo. Say hi. You'll see us coming in and out of Hatcher Pass with that, and that's basically to cover forecaster travel. That's from a grant. Let's see. We did some assistance with an avalanche hazard index that's currently being conducted and contracted for the DOT as to how there'll be some recommendations that come down the line as to how to handle the avalanche situation on that road. So there may be changes, maybe not. Again, the recommendations will go to the state. The state will decide on their budget and what they can do. But there could be some good changes coming there in the future. It's probably a 2-year process. And then just general conditions up at Hatcher Pass have been a pretty warm start, like it's been in most places. And you may have seen the pictures of all the glide avalanches. It was a pretty widespread problem. But with this cold weather, we've transitioned to a completely different regime. Glide cracks are no longer a big issue. And we have about a foot of powder up there. And the biggest concern right now is loose dry. It's our favorite avalanche problem out of all of them because it's the easiest one to mitigate, and it usually comes with great powder skiing. You may see an avalanche or two up there in that new snow, but it's pretty isolated. So things are looking very stable and good unless we see a change in winds or temperature or big weather changes. Make sure also to find us on Facebook and Instagram, because while we produce those 2 forecasts a week, we do frequent the social media place and give people updates as to what's going on, whether it's events, this event, or just snow conditions or weather changes. So make sure to look us up there and follow us. And don't forget to press the donate button. That's what's made this all possible. We just rely so heavily on the community support. So please visit us and press that button. So many of you already had. Thank you so much. And I'll let that roll on to the next.
Awesome, Jed. Thanks. Lots of great advancements for you guys. So thanks for passing those on. Next on our list is Gareth. Gareth, are you there? Gareth is with Valdez Avalanche Center.
Yeah, sure am. So I don't have a lot of updates for the Valdez Avalanche Center right now. So I'm going to take my time I have to talk with you about the weather and snowpack from last season and how it affected recreational use in Valdez. The winter of 2021 was an interesting one that looked average on paper, but actually had some significant weather events and a few dramatic weather pattern shifts of note. Since my time is short, I'll just briefly go over our season summary leading up to the spring. From the last week of November through third week of January, our area saw active weather with fairly regular snowfall events. In that time frame, we received 324 inches of snow with 29.2 inches of SAAW, or snow water equivalent. This was measured at DOT 2,700 feet on Thompson Pass. And then after the third week of January, we had a major pattern shift where we entered a period of below average temperatures and very little snowfall. This drought lasted from about the third week of January until the middle week of March, so about a 2-month period. Then we received about 50 inches of snow with only 3.3 inches of SAAW. This pattern change caused a significant amount of faceting to occur within our snowpack, and not so much surface horror because we had a lot of moderate to strong winds, kind of blew that stuff down. But what we got the most of was significant near surface facet formation, as well as a general faceting of the entire snowpack. This was especially apparent in the continental zone, colder, higher vapor gradients, that kind of thing. As the drought ended in mid-March, our area began to receive the normal significant increase in backcountry users, and small storms began to build shallow slabs. These were initially reactive to human triggers, but they weren't given a lot of attention by backcountry users. They were generally small and manageable due to their low volumes. As these small sporadic storms continued to build depths of slabs overlying our weak snowpack, our persistent weak layer became a deep persistent weak layer. And at this point, human triggered avalanches became deeper, wider propagations, and near misses began happening among all the user groups during the last week of March, first week of April. The user groups I'm talking about are backcountry skiers, snow machiners, snow machine assisted backcountry skiers, and helicopter skiers. There was a few factors that contributed to the amount of human triggered avalanches during this point. And first was just the simple nature of deep persistent weak layers and how they often don't exhibit the normal surface red flags like collapsing, shooting cracks, and people's shallow, hasty pits probably didn't cause any reason for concern. Secondly, day-to-day weather wouldn't have raised any major red flags for users. We didn't have many major snowfall events during that period. Temperatures remained below average for the time of year, at least through the first week of April. And lastly, and I believe most important, was the presence of a unique snowpack to Thompson Pass for that time of year. Most, if not all, of the near miss events involved someone in the group that had a fair to significant amount of experience in the Thompson Pass area. Our zone typically develops a snowpack where persistent weak layers are not as common in the spring, and instabilities are generally confined to the surface. So many users have likely become accustomed to this setup, and I believe that many people's decision-making was based upon past experiences and not the current state of the snowpack. So I believe there's the possibility that if weather patterns continue to change, potentially become more drastic, there exists the potential for persistent weak layers to become more common in the spring, and there be an increase in human-triggered avalanches / accidents. This is yet another great reason to follow your local avalanche center and donate to keep us going. Regular forecasts will get going on December 1st. Thanks for listening.
Thanks, Gareth. So you'll start up December 1st. Is that what you just said?
Yeah.
Cool. And then your experience there from last year is similar to Andrea's talk at the beginning of this, where it made me think about that.
Yeah, absolutely.
Cool, thanks. Hoots, you're next on the list. Cordova Avalanche Center.
All right, thanks, Wendy. I don't have much to say except thank you all for being here. I appreciate all the presenters. That's really nice to see all your faces again. And everybody that's joined in, I hope you get something out of this. Getting back to climate's been kind of a big topic today. And last winter, Cordova had a fairly cold winter, relatively speaking, where we didn't have our meltdowns. We got snow down to sea level and it stayed down to sea level, which is a nice surprise for us. I expect that to continue this year as well. I had a couple charts. I don't know, Melis, if it's worth even bringing them up, doesn't even matter. But I've seen a trend that was looking like the slope on the temperature line was at 0.25 degrees Celsius. Thanks, Melis. Okay, so this is the 5-year average of that. Can we do the other one first? Is that possible? But the slope on it is showing that in 100 years that our average winter temperature would be about this one. It's only 16 on this one, but that's because of the last 2 years coming down. But 16 degrees Celsius in 100 years above, pretty much zero. So you're getting pretty warm for an average winter temperature. But if you can flip to the other chart, Melis, it gives a 5-year average. It's kind of showing more of a trend. This is local to Cordova. This is at 1,500 feet, which is the top of our ski hill. And right now we're at the top graph. You can see we're in the downward trend. And in the bottom graph, you can see we're in the upward trend with the maximum height of snowpack. Speaking of this, I had a friend ask me about global warming years ago, how that was going to affect avalanches. And this person wasn't an avalanche person, but it's a good question. And I was wondering about that. I was like, well, if it's warm enough and we won't have any snow, so we won't have any avalanches. But I think the reality that the takeaway here is that it's not global warming, it's climate chaos. And if you think about it that way, then we're going to have more energy in the system, meaning bigger and more dramatic systems passing through, more unpredictable systems. And I've seen that looking at the weather models, at least personally, I thought I had a good handle on it and being able to find our weather windows. In Cordova, I consider us the armpit of Alaska, meaning that it's warm and wet. And it's to get out and enjoy it, you got to find that weather window in between that warm and wet period. And it's become increasingly difficult to predict that looking at the models. And I'm wondering if the models are having trouble keeping up. Carson, Kyle, you guys are the meteorologists. You could probably answer that question way better than I could. The other thing I wanted to say was I put a comment in earlier about the technology to keep us safe. The biggest things I try to teach people is situational awareness. Be observant of everything and think about how that's affecting everything, and constantly be reevaluating that. Situationally, aware of your situation, where you are in that situation. And what goes along with that is knowing your escape routes. Think about that, before you're ascending, before you're descending. Where can you go for safety? Where is an avalanche going to travel? And finally, we talked about this as well, but the biggest thing is communication with all your partners, with all other groups. Even if you're traveling by yourself, communication with yourself. That's the trickiest part. And so, yeah, that's all I have to say. I'm thinking that we're going to have a decent winter again here. If any of you all want to come down to Cordova, again, it's weather windows. So I wouldn't come for a day. I'd come for longer than that. We've got a decent ski hill here that has 1,000 vertical feet, and hopefully that'll be running all winter. Good backcountry side hill access from there. And yeah, my door's always open. Email me, give me a call anytime you want. All right, peace out.
Thanks, Hoots. You're gonna end up with a bunch of people on your doorstep. Next high pressure. Thanks for the update. Next on our list is Jeff from Haines Avalanche Center.
So thanks to all the organizers, speakers, participants, and all the other Avalanche centers doing important work. We're getting our first good winter storm here in Haines today with snow at sea level. We had a slow start with some snow at higher elevations, early fall, and that produced a share of mid-elevation glide avalanches. The Haines Avalanche Center has had exciting growth within our organization and will begin forecasting in a couple weeks. We were written into the Haines Borough budget this fiscal year, and that has allowed us to expand our forecast team to 4 part-time forecasters. So this includes Eric Stevens, Tim Thomas, myself, and our new hire, Brady McGuire. Brady works locally as an EMT with the fire department, is a search and rescue volunteer, and brings years of guiding and mountaineering experience to the team. We plan to issue 4 to 5 forecasts per week with the additional help and funding. Due to the ongoing COVID-19 travel restrictions to Canada, we will only issue forecasts for the LUTAC and transitional zones, but encourage observations from the Haines Pass. For education, we plan to host an Alaska Avalanche School Avalanche Rescue, Level 1 motorized and Level 1 recreational, along with a Level 2 recreational at Eagle Crest in Juneau. We will also provide free public education programs and outreach locally through the AIC Learn and Return grant with the Alaska Department of Public Safety and the Alaska State Troopers. Normal operations will continue, including maintaining weather stations and submitting professional observations. Our Mount Rapinski weather station is operational, but is in need of funding and repair. It was completely buried during last season. We measured about 90 inches of snow water equivalent at 2,500 feet in April. A new weather station was installed by the DGGS near the Beach Road landslide for ongoing geohazard monitoring and tracking precipitation amounts. And this station is included in our HAC precip tracker that can be found on the Haines Avalanche Center webpage at alaskasnow.org. And it helps to provide snow and non-snow goers a way to compare current precipitation amounts with historic highs. We also added a new webcam to the Haines Pass weather station link that was installed by the Yukon Road Weather Information System. And in other news, we have 2 interns deemed our snow rangers. We have Sean Reed and Beth Benhouse that are helping with operations that include maintaining a daily weather history, fundraising, and public outreach. They are both registered for Pro Ones this season, which we are stoked about, and we can't thank them enough. So a big shout out to all our sponsors, donors, and members in the Alaska Avalanche Information Center who all make our service possible. Contact us via alaskasnow.org to become a sponsor, to donate, or sign up for a membership. So we encourage folks to visit Haines this season for our world-class winter recreation and typically big snowfalls, and to use alaskasnow.org to keep up to date on conditions and stay safe in the backcountry. Thanks, everyone.
I think that bark is perfect timing. Thanks, Jeff. Thanks for the update. I wonder if you'll get 90 inches of SWE again this year. Next on our list is Mike with the Coastal Alaska Avalanche Center. Mike?
Hey, Wendy, you got me?
Yep.
Hey, thanks for organizing this, Wendy and Melis, and probably everyone else that did it. Good stuff. I appreciate it. I am on the board of the Coastal Alaska Avalanche Center and just kind of want to introduce it to folks so that you know it's out there. We're relatively new, although we were running some products last winter. We are currently not forecasting like some of the other centers that might come down the road, but our initial goals were to get an observation sharing platform and some basic weather data up online. So if you go to our website, just on the avalanche.org site, you can find those products. And it's been pretty encouraging to see how quickly folks have been starting to submit observations, because we just didn't have anything before out there for people to share and a central place to get weather data. So we're kind of just in the building phases, and we've been trying to get partnerships. You got the local brewery, Devil's Club, has a beer that they're making for us, and Jed and his crew up at Hatcher Pass has been really helpful in giving us like some lessons learned and some templates for things so that we can really just kind of get off the ground and going and build this thing up. So that's kind of really where we're at, is just building this center up so we have a good observations platform, and maybe down the road forecasting. And the other thing we're going to try to kick off sooner than later is a scholarship program as well. So those are some of the things that that we're working on. But yeah, so we're relatively new, but we're gonna you'll hopefully be seeing more of us, and as we kind of expand what we're doing through the upcoming years. But
Awesome, Mike. Thanks, and it's great that you guys have been able to make the progress you've had as quickly as you've had, actually. So
yeah, the only other
work.
thing I forgot to mention is that we also have on our observation site, we have a Sitka zone as well as Ketchikan to try to help fill some of the gaps there, because those communities have small but diehard and increasing user groups for a lot of them. So that's kind of on our radar for future outreaches, to continue to make some connections with folks in those locations as well.
That's excellent. That's a good segue. You're doing observations and weather stuff right now. And then we have from the Eastern Alaska Range Avalanche Center, ERAC, Mark Lockwood. Thanks for being here.
Yeah, great. Thanks for having me. Can you hear me?
Yeah, we can hear you.
Yeah, Well, recognize a few faces here, and thanks again for all the other presenters. Great informative day. The Eastern Alaska Range Avalanche Center's been a little bit, slowed down due to COVID. We did last year pull off a snow machine training at McLaren Lodge on the Denali Highway. And our weather station is up and active at Rainbow Basin. Looks like we're tracking about 4 feet of snow up there now. We're in the process of trying to figure out how to get more weather stations. We have through the university, the actual implements and equipment, but it's just trying to find how to get these spots permitted and come up with the bonding, because of having batteries up there. You've got the problem of hazardous materials in the permit, so you got to have some bonding to go behind these things, is what we understand. If anybody has any other ideas on that, or how you've accomplished that, please reach out on that. We just had some elections and got some younger blood in there for some board members, and a mix of skiers and snow machiners. And that's one of our big things in Fairbanks is trying to get into that snow machine community and get the word out. We do have some good, I don't know about sponsors, but REI has us in there for awareness training, and the snow machine businesses bring us in, and we usually have a pretty good turnout when that goes on. So yeah, we're up and running, and things are going well. So
Great. Thanks for being able to do that right now. And good luck getting all those things going. And I know those other things can get big. So that's great that the community comes out for that. I'm last on the list. I'll give a quick update for the Chugach National Forest Avalanche Center. We do have a little small chat staffing change, or large, but there's 3 of us, myself, Andrew Shower, who was here last year. And then we have a new forecaster, John Sykes, who we stole from the Alaska Avalanche School and a PhD program. So it's myself, Andrew, and John this year. Then we have Alan Dahl, who's been through the Alaska Pacific University Snow Science program. He's going to come on as our intern. So that will be fun to have Alan. And everybody was pretty jealous of Hatcher Pass's Are You Beeping signs. So from a lot of chatter from the community, we have 2 Are You Beeping signs, thanks to our friends group working through ConocoPhillips grant, who actually were able to pay for that. So they're going to go up in the next 2 weeks. That's awesome news for us. That's new, and I think the community alike. And other than that, we're going to be hosting some forecaster chats. We're going to do a few outdoor events at some Blue and Gold and potentially a couple other shops around town. Those are getting scheduled right now and will be on our calendar next week, but that'll be December and January. And then March 19th, we're going to host Avalanche Information Day at Turnagain Pass at the motorized lot, and everybody's invited. Bring your tent and camp out if you want. I think it could be a pretty fun outdoor event, and you'll probably hear more about that. But those are pretty much our big updates, kind of short and sweet there. I don't think I missed anything too big. And of course, thanks to the Forest Service, that is our employer, and our friends group, that is 50% of our budget. And so all of us, donating to our local avalanche centers is a big deal for everybody here. And thank you. And I will pass that off. Oh, I just got to know where the Are You Beeping signs. They're going to be at Tin Can in the motorized lot. And Melis, I'm going to pass it back to you to close up the workshop. I think you have a couple things, just saying thanks to our sponsors. This it really is a group effort. We have several people on the committee behind the scenes, and then of course we have these sponsors that help put it together.
Yeah, I can't thank all of the panelists enough. A ton of work goes into getting the slides and the data and the presentations ready, and dusting off Zoom cobwebs, and making sure everybody has the technology to be able to present. So that all has been huge. Big thank you to the American Avalanche Association. They sponsor all of these regional SAAW events throughout the country. And so that's been enormous for us. The Friends group, they're the driver of this event. They collect, all the money and give us the resources to be able to put on this conference. We're really hoping for an in-person 2022. It's so much more fun to learn and celebrate with everybody in person. We had 206 attendees today, tuning in and out over our 4-hour span, and 16 panelists. So that was a huge effort. We want to thank all of our local sponsors, Powderhound down in Girdwood. This is their second year sponsoring the event. Obviously, thanks to Alaska Avalanche School for a lot of the infrastructure for the event, Ski AK, beloved local ski shop for supporting SAAW this year, Chugach Powder Guides for helping us get all of our corporate sponsors, Blue and Gold Board Shop. Jason has been an amazing supporter of Avalanche education in the community. Nick at AMDS, I love everything that he's doing to help us expand the reach of motorized avalanche education. Don't forget, tonight at 6 p.m. you can show up with your buddies and your transceivers and go to their shop. You can join me, Wendy. So yeah, Mike Duffy's going to be doing skills drills with folks. Backcountry Access, Bruce Edgerly, again, he comes to Alaska every year. He works with a lot of local sledders. He works with us at the Avalanche School to make sure we got good equipment to teach and ride with on our courses. Mammut North America has been fabulous. We love working with those guys. So I am going to just invite Wendy into the screen fold. And say thanks to everybody.
Yeah, thanks everybody for taking your Friday afternoon. I know a lot of people probably would have liked to have been powder skiing, but it's gonna be good this weekend.
Should be pretty good. We hope to see you out in the hills. And we'll be sharing this recording. I could probably even send it as soon as tomorrow to attendees, and then we'll give it a week before we share it with people that didn't commit to attending the event. But thank you all so much. We'll stay on just a little bit longer in case other questions show up in the chat.
Thanks, everybody. Have a good Friday night.